Hello everybody, here we are, and let's simply get going from here on, and we will work on the project for the coming 3 hours. Let's see how much we are gonna be covering. And as for the status of the live, let me check that, and it should be fine. That's right. Hopefully it should be fine. Let me copy the link as well. Again, I'm gonna be sharing the link in the group. If you haven't joined the group yet, do join that. You will find many people like you doing the same thing, so you can just simply get in touch with the people too. And it's better to learn together than learning alone. Of course, you must get the idea. Okay, by the way, let's simply go ahead and one thing I'm gonna be doing here, that is simply sharing the link. Hopefully, okay, this is not done yet. Control X, Control V. Sometimes it doesn't load in one go. Okay, now it's loaded. That's another case. Yeah, but once this thing is done, I'll just simply go ahead from here. And coming back to this particular section, so we were here. Correct the logic of assigning a new host. This logic is not working the right way. Why is that so? Let's simply figure it out. So what do we have to take care of? First of all, it should be running properly. Everything's running properly. After that, I have two browsers over here. Let me have them side by side. Coming back to this particular thing, and similarly, uh, I'm gonna be joining the same meeting from here, from the Chrome side. Alrighty, this thing is done. Just a sec, give me a moment. Alrighty, so the goal is gonna be to just simply get it done as soon as possible. And but before even that, uh, we'll have to first of all fix this bug that we are facing. In order to do this, let me restart my backend again, because first of all we'll have to know where we are actually struggling, and then we'll be able to fix that. But before even that, if we don't even do that much, then again this is gonna be almost next to impossible to do anything. So here I allowed, and things are working fine. So let me inspect it. Let me go to Redux, and if you actually have a look over here, so I have a current participant that is not a host. I have other user that is actually a host here. So okay, this is fine. Now what happens if host leaves the meeting? That is what we have to take care of. So what happens when host leaves the meeting? Other host is here, current participant is here. Let me close the host panel. So at this particular point of time, I still have the current user, I still have this host. This is insane. Rather, this should not be done, but this is happening like that. So what can we do now? Whenever somebody leaves the room, aren't we just simply removing that from other participants? We are. How about the other participant? Other participant is still false. That simply means the participant is not being made as host. Okay, coming back to this thing again, and of course I'll have to restart it. How about when I just when a normal user leaves the room? Let's check that too as well. So reload the page. So this is the normal user, current participant. Okay, once this thing is done, copy it here, paste it here. Of course I'll have to allow from here. So let me even allow all for now. Once allowed, what happened? I got my other participant. If the other participant actually leaves the room, then this became empty. Okay, so one thing is not working as expected. What is that? When the host leaves the room. So let me go to the server, and here I'm just simply handling this. And first of all, if the host is leaving the room, left participant is gonna be equals to is host. Then what am I doing here? I'm selecting a random participant, ultimately participant as the 0th index, and then new is host true, meeting dot is host, setting the value over here. So ultimately I got the new participant, new host, added the value in the new host. So this is even fine. And once this is done, after that, inform the new host about himself. So WebSocket message, sending the message. So state should be changed, but the state is not quite changing, so I will have to even track this particular thing, exactly what happens here. And let me go to the front end side and mail inside signaling.tsx. Label signaling.tsx. Over here I'm getting the message handle normal process, and inside that I'm gonna be handling what? I'm gonna be handling handle connect host. What am I doing here? I'm gonna be getting the host, that's okay, and once I got the host I'm gonna be just simply setting it. So getting the host and simply setting it, that is also fine. I mean, this should be fine as well. Just simply sending the host from here. The message will only be sent to the host only, so no need to worry about that too. So yeah, fine with this. And once this is done, then I'm sending message to the others. Okay, so let me check one thing. Am I getting this host message here? Connect host. So let me do it one more time. Of course I'll have to restart my backend. Start it again, reload the page. So first of all, what is happening? Connect host. So host got connected, that is great. What about after this? So after this, another user will try to join the meeting. So maybe this is the user who is actually trying to join the meeting. In that case, I will have to allow from here. So let me simply click on allow. As soon as I allowed a request to join meeting, I think whenever a user tries to join the meeting, at that time it comes automatically, and after that inform others about the new participants, that is also fine. Coming back to this one, console, and over here what am I doing? Inform new participant about others. That's great. I'm informing new participant about others. How about when a user leaves the room? So if this particular host leaves the room, I don't get any event over here. Why is that so? Disconnect happened. Okay, this particular function ran, but at the end of the day, the event is not emitting. So ultimately, host is leaving the room. When the host is leaving the room, so let me do one thing. Disconnect CLG meetings, and not only meetings, rather I wanna merely check about a particular meeting. So in that case, this particular meeting, once I got the meeting, CLG log the value of the meeting. Once I got the right meeting, I'm gonna be returning from here as well. So CLG meeting is gonna be equals to meeting. Initially it is like this. After that, inside meeting I will have my participants, and turns out I'll have to restart it. Alrighty then, came back. The thing is that suddenly the network got disconnected, and because of that thing I had to just simply leave. Coming back to this one, console.log meeting when the user leaves, and lastly over here CLG meeting when normal participant leaves meeting. So this is how it's gonna be going on. By the way, should be host list. That's great. Let me run the backend, and this time it's gonna be a bit different. Rather, I will be getting the ultimately I'll be getting the log messages and all. So right now connected, that's great. And once connected, and now another user will connect. So let me close this, actually have it here, and now the other user joins. Coming back to this backend section, still nothing. And if this user leaves the room, first of all I'll have to no doubt allow. So let me click on allow, and once allowed, the user joins the room, and as the user joins the room, grant joining permission. That is happened. That's great. What is the next thing? The next thing is that what if this user leaves the room? Okay, as soon as this user left the room, I got this thing here. So ultimately what happened, the meeting, it was like this. There was this host inside the meeting, username, and there were two participants here, first and second. And after that what happened, when normal participant leaves, because of course that is not the host, so when normal participant leaves, at that time host remains the same. That means id 40, and earlier the host was with the id 40, so ultimately host remains the same, and host was also the part of this participant, and the another was e5. So ultimately e5 left the room, ultimately user containing e5. So that is simply means host remains in the room. So this works when the host the normal participant leaves the room. How about allow it right now, and as soon as I allowed it, this time host itself is gonna leave the room. So let me just simply do it like this. Okay, host left the room. Then what happened, when host left the room, host is 40, participant 40, participant 75, this got connected. When normal participant leaves, so ultimately host remains the same, and 40 here. How about when host leaves the room? One more thing, whenever a participant joins, I'm gonna be logging the value. So as soon as the participant joins, in which case the participant joins here under normal process, handle asks to connect, and ultimately whenever I get the message, at that time I'm gonna log the value. So whenever I get the message over here, so at the end of the day, clg on message, what will I do? I'm gonna be rendering the meetings. Not even meetings in the sense all the meetings are gonna be rendered here, and that is okay, not a problem right now, because there's gonna be only one initially. So this is what I'm gonna be doing. And as for this thing, it is stopped. Let me run it again, and this user is gonna join the meeting. Ask to connect on message, that is empty. Of course I don't have to have it here, Control X, I need to have it at last here. Okay, let me rerun it. Come here, reload the page, and this time I have this meeting ID. This meeting ID contains the host and the participants and all. So ultimately it does contain them. Having said that, I can't get the participants directly over here. That is fine. Okay, and what happens next? There is only one participant right now. Another participant will try to join the meeting. Suppose this one tries to join the meeting. So still same, I'm gonna be allowing from here. So let me allow all from here. So as soon as I allowed all from here, so ultimately host is 4B, and there are two participants right now. Okay, now what if the host leaves the meeting? Which was the host? I think this was the host. So if this host itself leaves the meeting, so what is happening? Disconnect meeting, host is still 4B, and that is okay normally in the meeting section. Participants, there are two participants. This is the participants 4B, and the another participants at 3. And then meeting, when normal participants leaves the meeting, so ultimately the participant who left the meeting, that was which one? I still have the same host over here as well, and ultimately normal participant is getting removed from the meeting. Okay, So what do I have to do? Even when the host leaves the meeting, normal participant is getting removed from the meeting. That simply means coming back to this particular section here. When it closes, at that time it's okay, I'm getting the meeting normally, meeting before, and let participant index is gonna be this and this. And once I have this, so let me have the CLG left participant, exactly which participant is leaving the room. Left participant, I have to check it. So again, all this is gonna be all about logging and all, so that I can just figure out what the problem is. Let me reload this page. So ultimately what happens here, uh, the host remains the same, there are two participants, that's great. Now what happens when host leaves the meeting? Just like this, host left the meeting. So coming back to this one, when this connection happened, at that time there was a host ending with 9A, and there were two participants. One was the host, another was another participant, that was HC. Now HC participant leaves the room, so left participant is actually the participants whose ID ends with HC. That's amazing. Meeting when normal participant leaves, at that time host remains there and HC gets removed. But the host left the meeting, didn't he? Why am I getting this? Left participant, how am I getting the value of left participant? Just a sec. How am I getting the value of this left participant? Left participant index, how am I getting the index? Left participant, meeting, and connection ID. So meeting participants, I'm gonna be finding the index where participant ID should be equals to connection ID. The question is, whose connection ID is this? More important question, whose socket server is this? I mean, web socket server is this? Whenever a request comes here, whose connection ID you are sending from there? The user's connection ID. So ultimately, let me check this thing. Meeting before, just below that, CLG connection ID. And not even here, I'm gonna be checking the connection ID. Okay, let's have the connection ID here. Connection ID. Let me have this before tag here, so that I can know that it is just happening everything before. Okay, so like this. Apart from this particular thing, whenever a user joins the room, so whenever joining happens, at the end of the day I want to print the connection ID. So whenever I get any message, at that time I log the value of on message, CLG on connection ID. So what I guess, or what I think, connection ID should be different for two different users, but let's see what happens. Of course I'll have to restart it. I got the problem, like the connection ID remains the same, and as the connection ID remains the same user is getting removed over and over. That should not usually happen. Let me reload it. A user joined, and as the user joined, I got the connection ID 49, and this is the connection ID of the host, and that is okay, not a problem. Let me ask another user to join the same meeting. Enter. I will have to allow from here. Let's simply allow it. As I allowed this, so what happened? Another user joined and the connection ID was CD, and that is completely fine, and that should actually be like this. So when another user joins the room, so for that particular user the message is on message. Of course this is the previous meeting, and ultimately the ID of the user ends with CD. The host ended with 49, and that is fine. Now if host leaves the meeting, what was the host? This particular section, right? Yeah. So if host leaves the meeting for some reason, so let me go up. So this is where disconnection happened. Meeting before meeting actually looked like this, 4949, and there was the participants ended with CD. Then connection ID of what? Connection ID is CF. Just a sec, which connection ID is this ending with CF? come quite close, but okay. So this is the host information that I got, and after that there were two participants, and just after that I got the connection ID ended with CD. That simply means the connection ID is the right one. Is that so? Even the left participant is the CD. No. I don't know what is the reason behind this. Okay, fine, coming back to this. On connection I got this CD, and that CD remains there. Hang on for a while now. When the connection gets established, yeah, right, just a sec. Coming back to server.js here, ts. Well, this is the region. Server is the same. Okay, now listen. Server is the same. So when a first person joins the room, connection ID, that person gets the connection ID, gets saved here. When the second person joins the room, that connection ID gets overwritten. So what is the solution to this? The solution to this problem, the solution can be getting the connection ID here itself. Socket connection is established. So instead of saving the connection ID globally here, that is the problem. So I'm saving the connection ID globally here. Instead of doing that, I'm gonna be saving the connection ID here. So in this way, this connection will be ID related to for that particular user only, and hopefully this time I should be getting the connection ID of the host. Yeah, this should work. This may work. Let me reload this. One dev. Come back to this particular section, reload the meeting, and of course I will get a joining request over here. So let me do that too, and allow it. When I allowed this, what happened? Coming back to this on connection, when connection happened 26. So ultimately, first of all, a host joined the meeting. So it actually starts from here. So host ending with 26 joins the meeting, and the ID is 26. Amazing. Now another participant joins the meeting on message, and on message. What was this? On message. Why am I getting it twice? WebSocket connection establishes. Okay, another user joins the room, and because of that thing, this on message, there should be two participants at the end. Okay, here they are. And once there are two participants, 26, and the on connection ID is still the same even when the second participant tried to join the room. Okay, the thing is that in WebSocket, yeah, this is a challenge that you will have to handle the ID related stuff on your own. In socket.io, it was having directly, it was getting done directly. But never mind, let's come back here. One, a user joins the room. Come back to this particular section. What happens? Asked to connect, normal, ending with B5, ending with B5, that is fine. Let me select this much. Ask another user to join the same meeting. Simple. I asked another user to join the same meeting, and as soon as the request came, ultimately I'm getting this 2D over here. Why 2D? Because the new user's ID ends with the 2D. That is fine. So ultimately this is the ID of the new user. Come back here, allow the user from here. Now I'm getting B5 again. Why? Because grant join permission. This is the server. Okay, got it. So first of all, I got B5 because the host tried to join the meeting. Now I got 2D over here because this request actually came from the other user. Now I'm getting the B5 here again because host will send the request again to the backend. So I'm getting b5 over here, which is so far so good. Great. What is the next thing? The next thing is that host leaves the meeting like this. Come back here. Okay, so disconnection happened. Once the disconnection happened, meeting before host was this, and there were two participants including the host and the participant ending with 2D. And now the connection ID before was what? The connection ID before was B5. Host did not leave the meeting. So why is the connection ID B5? Left participant is the B5. That simply, oh, host is leaving the meeting. Come on, yeah, this is right. Okay, finally this is right. I'm lost in my own world. I'm getting B5 over here. So as the host left the meeting, so I'm getting the ID of the host itself. That simply means is host is true, so ultimately that host is leaving the meeting. And as the host is leaving the meeting, so meeting when host leaves the meeting, ultimately this gets triggered. An amazing job. Ultimately we get another participant over here, and that particular participant is gonna be the host. And when normal participant leaves the meeting, so host left the meeting, and then we are informing others. Great job. That simply means this particular user should become the host now, and as this becomes the host, if I join the meeting again, so I should be getting a request here. Amazing job. This is done. So ultimately, as soon as host left the meeting, the another participant became the host. And if this host leaves the meeting, then this participant has become the host. Simply means if other participant tries to join the meeting, so I should be getting a request over here, and this what left right will keep happening. Okay, amazing job. We've solved it. And the error was here that we were actually storing the value of connection ID globally. So that global value was changing over and over. Rather, the connection ID should be related to that particular request. That's it. So this is what we have to keep in mind. Oh, finally, yeah, this is done. Okay. Cut. Overall logic is right. There was only one problem, that was in the connection ID. Like I was storing that globally, and that value was getting overwritten over and over, and because of that thing I wasn't getting the expected result. So ultimately this much I've done, and let me close this now. Okay, this thing is done. So whenever participant leaves, that's great, the job is done. What is the next thing? So correct the logic of the host, done. Let me cut it. Toast when a user joins the room. That's great. Whenever a user joins the room. So when a user joins the room, newly joined user, right? Yeah, newly joined user. So do I have this particular state over here? State, not this state. I have to go to my front end, meeting.ts. I do have newly joined user. Do I have this set newly joined user? I have set joining participant, remove joining participant, all these things. Left participant, remove left participant, add a new participant, set other participants, set host, set current participant, but I don't have set newly joined participant. I even need to have the value of the newly joined participant over here. And this is gonna be on the client side. So newly joined participants in the sense what? Newly joined participant in the sense whenever a new participant joins the meeting, what will I do? I will actually save the value of the new participant over here. But there's another problem. And what is that? What if many people join the meeting at the same time? If the many people join the meeting at the same time, others will be informed about those participants one by one, and this value will keep getting changed. But not just this. As those participants are getting created, participant got created. Okay, so it's like there were 10 requests. I allowed them all. As soon as I allowed them all, one by one request went to the server side. Then server, because they were joining the meeting and I allowed them all, so ultimately they will be informed about others, all 10 people, and others will be informed about them. That is fine. And what will happen next? As others are getting informed about them, they will create their peer connections. Yeah, they will. Once they are creating their peer connections, and others will have to create the newly joined peer connection, right? And when others are getting informed about the new participant should not be able to create the offer. Offer what? This is related to web RTC section. So new participant should not be able to create the offer. That is why I need to have it here. And others will create the offer. They will send it to him. That is great. And what if in between another participant joins the meeting? This will be not a problem, because creating the offer and all these things happen really quick. So they'll be done really quick. So ultimately offer will be created, that will be sent to the other client. Still, because I am allowing all the participants over here, that will become a problem. Allowing all of them one by one, that would not be a problem, because I'm allowing or denying the participant one by one. So if I allowed it, the request will go to the backend, the others will be informed, they will create the peer connections, and once others create the peer connections for this new participant, this new participant create the peer connections for others, the connection will be established. And in this case, what is happening? Many requests are going to the backend at the same time. Many people are getting informed about new participants over and over. So the value of this newly participant will keep changing. That is the problem. That simply means if I am a participant, many people will try to make a peer connection to me at the same time. That is right. So how will I handle this? Because now there will not be only one newly joined participant, rather there are gonna be many. But just a minute. Alrighty, for some reason this keeps getting disconnected again and again. So what I was saying, coming back to this. So host allowed 5 people at the same time. So I'm a normal participant. Host actually allowed 5 people. As the host allowed 5 people, what will happen? The request of those 5 people will be sent to the backend one by one. So server will receive those requests one by one. As the server receives the request one by one, let me actually keep it here. As the server receives the request one by one, then what will happen? Server will receive it. Once the server receives it, then after that it will inform each other, right? So I'm normal participant, host allows 5 requests, request will go to the server, then everybody will be informed. Everybody will be informed means what? I will be informed. So this participant is going to be informed. So as it got informed, it got the newly joined participant. As it got the newly joined participant, what will happen? It will create the peer connection. The peer connection will be created, and it will create the offer. Send the offer to the newly joined participant. Newly joined participant. But the problem is, the host actually allowed 5 people at the same time. So I will be informed about one, then the server will process the another request, then I will be informed about another newly joined participant that I got earlier, that I got informed. Suppose this is in the process, that I got the newly joined participant, I got informed about this one, then I created the peer connection. The offer is yet to be created, or maybe the process is in the background, and I still have to send it to the new participant. but suddenly what happened, I got informed about other participant as well. So this participant got informed about newly joined participant number 2, suppose. In that case, again peer connection will be created, offer will be created, sending will happen to newly joined participant 2. Can it actually handle the things like this for more than one user at the same time, or will they just collide, or will they just interrupt each other? First of all, the value of this newly joined participant will be changing over and over, that is right. And as the value is changing, so there are gonna be many toast at the same time, many messages at the same time, and that is fine. By the way, if I'm getting many messages at the same time, they are gonna be processed one by one, so that is completely fine. Apart from this particular thing, newly joined participant 2, then newly joined participant 3, then newly joined participant 4 and 5. So once a participant joins, peer connection will be created, then offer got created. Once the offer got created, it will happen automatically, by the way. As soon as somebody joins, then I have to send the offer to that particular participant. So via WebSocket I will be doing that. As I have the info of the newly joined participant, I will be able to send the offer there. Then I will have the wait, do I really have that? And once the offer got created, it will be sent, and once it is sent with the ID, then I will get another, hopefully it will work. But let's see, if we get any errors, then of course I will be fixing them. But overall what I think, the process should be synchronous. That simply means, first of all, one of them will resolve, then another, then another, then another. In this way, it should not collide, the requests should not collide, or at least they should not interrupt the paths of each other, and this way it should be working. But again, it will be clearer when we actually implement this particular functionality. Before that, who knows. Okay, so let me set it, newly joined participant, right? So let me do one thing, create another method. This is at the third number, so let me just have it here, maybe somewhere here. Set newly joined. If it doesn't work, then of course I will have to create make it an array, and that okay, it's not like it is the dead end and we can't really go ahead. So newly joined participant, what does this do, by the way? This is nothing but an object, so I will get newly joined participant. Again, the type is gonna be participant. What will it do? I will be setting the value of newly joined participant. This is how I'm gonna be going ahead. I need to have comma here, so this is how it's gonna be done. Again, this is the new action that I have created. Below what? Below left user participant. So left, set left. Okay, let's keep it here, newly joined participant, and the type is actually gonna be participant. It will be returning void. So this particular thing is done. Close this, close this, close this. Toast when user joins the meeting, right? Okay, fine. So once I've done this much, after that the value is going to be set. Is that so? So whenever a user joins the meeting, at that time I'm informing others. What am I doing when I'm informing others? When I'm informing others, okay, on the front end side, right? Today, I don't know for what reason. I keep facing this issue. This network, it keeps dropping. Never mind. Coming back to this. Const set newly joined participant use meeting dot get get state dot newly joined participant. Once I got that, so I'm gonna be setting it here too. Set newly joined participant, new participant, create peer connection for the user. Of course I have to create the peer connection as well, but First of all, this should happen. Okay, we've done this. And as soon as I have newly joined participants, then what will I be doing? Once I have that, so I will have a what toast for this. So coming back to page.tsx over here, I will have another use effect just exactly like this. So let me copy it, paste it here. This will be dependent on what it, even this is gonna be sort of like this only, but this will be newly joined participant, and I'm gonna be getting the value of newly joined participant. This is how it's gonna be going ahead. The overall use effect will be dependent on that. If I have the newly joined participant, post.warning join the meeting, and I'm gonna be getting the username. So this is how it's gonna be going ahead, and let's see how it's gonna be working. Okay, it's time. It's show time. Don't know whether it's gonna be working right or not. Reload the page and reload this one as well. I'll have to allow, and username join the meeting. That is okay. One user tries to join the meeting. Let me do it again. Let me allow it from here, and username join the meeting. Two users join the meeting. That's great. Let me copy it again. Let me paste it here again. Let me allow it again, and three users join the meeting. That is okay. Now this user leaves the meeting. This user also leaves the meeting and then tries to join again. This user also leaves the meeting. So now, right now, what is happening? Three users are in the queue, and now I have to allow them all. What I expect that the process should be done sync. Just give me a moment. Whatever. Just give me a moment. Let me fix this. Alrighty, hopefully now I will not be facing that. Otherwise, this is gonna be crazy. I will fix it, don't worry. After the break, like when I take a break after 2 hours or 3 hours, maybe, don't know. So I will just fix the whole thing. I just changed my set. Alrighty, starting the live again, and hopefully this time I will not face the network issue. I will definitely fix the setup rate. I mean, get the setup ready the best way possible. But for now, excuse me with this. I mean, I know I'm struggling with this quite a lot, but hopefully the voice is clear. Yeah, everything's clear right now. Let me go ahead and yeah. So let's continue with this. So what was I supposed to do? The next thing that I am supposed to be doing here, and that is creating the peer connection. So congratulations. This is the time when we are gonna be going with the main logic, WebRTC logic ultimately. Signaling server server.ts. So toast when user joins the room. Leave room logic. Yeah, I haven't implemented this yet, but we will be implementing it later. Leave room logic in the sense that red button, this red button, if I click on this, so a user should be leaving the room, and right now I'm redirected to the home screen, and that is okay. As soon as I click on this, I'm on the home screen. That means the meeting got ended. But before that, we should give a pop-up that, okay, do you really want to leave the meeting and all? Okay, we are not doing that, but we will work on that. Okay, not really big problem. What is the issue? And three users actually left the room. That simply means I should not have those users here, but let me check if I have them. Redux. So left participant, I have a left participant. Okay, that's fine. A newly joined user, I do have that, and then current participant, I don't have other participants. These two values, they need to be reset. They need to be reset in the sense a left participant should be reset when. So this was the last newly joined participant. This was the last left participant, they are contain these values, but this should be reset as well. So left participant should be reset whenever the participant actually leaves. And when do I have to reset? I have to reset in this particular section. Let me close this and then I will start working on the connections and all. So let's not worry about that. I need to go to the handlers, sorry, the meeting page, page.tsx, API font meeting page.tsx in here. And as soon as these two things are happening here, so left, whenever left participant changes, so ultimately what am I doing? I'm just simply toasting it, simply showing the message to the user. And after that, once the message is shown, then I need left participant again here. Many states I'm getting, and kind of quite many, but never mind. Const, or I just need to copy and paste the stuff because they're gonna be coming from the same place. Set left, I should not be like that. Set left, whoa, literally, is that so? Am I not gonna be getting the even suggestion? Set left, now I'm getting that. Set left participant, set left participant, just like this. And similarly control C, control V, and then this is gonna be set newly joined participant. Just wait a sec, copy it. I'm gonna be showing you exactly what am I gonna be doing. So whenever I have shown the message, I'm gonna be setting their value to null. Is that so? Do I need to do it? Newly joined participant should be there, but this left participant doesn't really play any role, so I can just simply set that particular value to null. Newly participant, I need to have that because I need to get some other things done, and hopefully all these things are gonna be happening synchronously, because if they don't happen synchronously, whatever logic I've thought of, that will fail. But hopefully that will happen synchronously only. By the way, left participant, set left participant, and that's gonna be equals to null. Use meeting. So ultimately left participant, no, empty object, just like this. Any problem? Is not assignable to type parameter participant. Okay, coming back to this. Newly joined participant, left participant can be null as well. Okay, but this type will not allow me, or will it allow me? No, it will not allow me. Actions, state, newly joined participant, left participant, it can be equals to null as well. Now I should not be getting the error. What is the problem? Null is not assignable to parameter. Array bhai, I am doing that, don't you think so? Set newly joined participant. It can be participant or it can be null. Any problem now? Not newly, left, sorry, left participant, this one. Any problem? No problem, errors are gone. Close this, and this is it. Now if I come here, if I check the value of left participant, that is reload the page of course, and it is equals to null, and let me keep it on the left side, and let me make another person join the room. Okay, this is done. Of course I have to allow. Why I'm not getting the option to allow? Interesting. That simply means server is not running. Burn. Come back to this particular thing, reload the page, and there is no left participant. Reload the page. Okay, I got the joining participant. I can just simply allow from here, allow all for now. So ultimately I do have the value of newly joined participant. I don't have the value of left participant. So if the participant actually leaves, like this one, so I got informed and the left participant is not still there, because for few milliseconds I got the value of left participant, and after that when did I have the value of this? Skip. in between. Okay, here I get the value of whenever set left participant I set it. So at the time I did get the value of left participant, and just after that it got set again and the value became null. Okay, so this is what is happening. Alrighty, this thing is done. Apart from this thing, what can I do? Apart from this particular thing, it's time to create the peer connections. Get ready for that. Okay, when do I need to create the peer connection? As soon as the users are connected, ultimately when I'm actually informing each other. So app, web, helper, normal server helper, and here handle inform others about new participant. So handle inform others about new participants. So others are gonna be informed about new participants. I will get the new participant over here, and that simply means now I have to create a peer connection. Creating a peer connection. Okay. Create peer connection. How will I create the peer connection? Okay, how will I create? That's another case. First of all, I will get this new participant's ID, so that after creating the peer connection, I can reference the ID to that particular peer connection. So first of all, new participant dot ID. I need to have this. Again, where should I create this particular function? Create peer connection. So let me go to lever, not even lever. And inside peer manager, I'm gonna be creating peer connection related stuff. But here I need to have some of the values. So first value, that's gonna be const peer connections. This is nothing but an object, and let me create the interface here itself, the type ultimately. So interface peer connections. What is going to be the type of this? This peer connection will have an ID, and ultimately it will have a key string, and will have its value, and that value will be peer connection itself. So peer connection itself. What is the type of the peer connection? Type of the peer connection. Socket. Nope, not socket. Type of a peer connection. PC. Let's search it online. Type of peer connection. Getting started with peer PDP. Type. For TypeScript. Nope. RTCP. Okay, it could be RTCP. RTC peer connection. Okay, this is the type. Got it. So peer connections, and again, what will this key be? This key will be nothing but ID of the user. So ultimately connection, I call it ID. So ultimately user's ID, this is gonna be, I can keep it key, or I can keep it just like this, or okay, let it be. I will have the ID over here. That ID will be referencing to the peer connection. This is how it's gonna be going on, and peer connection, this is how it's gonna be going on. So ultimately I have my peer connections like this. What all do I need to maintain here? Inside peer manager, I will have my peer connections. What else? Peer manager. Const. I will have RTP senders. What are these RTP senders? RTP senders. RTP sender is again gonna be an object, and this will contain actually many things. But first of all, overall things are gonna be the same. Control C, Control V. It's gonna be just like this. It will have an ID, and again it will be the type of RTP senders. This is gonna be the type. So let me assign the type over here. What are the RTP senders? Whatever, if you are sending video or audio, you are an RTP sender. Okay. And what will I be doing here? RTP senders, they will contain an object inside themselves, and ultimately ID will be referencing to an object, and inside that object there's gonna be audio option, and that's gonna be RTP audio. What is the type of this? Audio sender will audio will be containing audio sender, video will be containing video sender, so it is gonna be kind of like this. So ultimately that's gonna be ID of a user, and that user, what that user is sending, that user is sending audio or video both, and all the things are gonna be here, and by default both the things are gonna be turned on. Okay, by the way, coming back to this RTP senders, when do I and why do I need them? I mean, why do I need to save the value here? There are two things. First one is the remote stream, second one is the RTP senders. I need to store the remote streams so that, okay, I need to store these senders over here so that I can replace the track. This is mainly useful when I need to share the screen. So I am sharing my camera is on, then suddenly I want to turn my camera off, or I can just remove that particular part and I want to replace the track with the screen. So at that time these senders are gonna be needed. By the way, coming back to this sender, RTP audio. Now what is the type of this? Type is the problem here. Type of audio sender in peer connection for TypeScript. Peer-to-peer audio stream using WebRTC. Okay, RTP peer connection. I will not get the type from here. Simple peer. Let me have a look at over here. Type of this type audio track, media stream track. Is that, nope, not this one. Media stream, not this one. Track stream. Getting started with the peer connection, just RTP peer connection. Bro, give me the type, please. I'm gonna be going to my previous project and getting the types from there. Media senders, media, RTP, media. I'm just guessing the things right now. What is the exact type? I'm gonna be going to my previous project and I will get the type from there. So project, not this one. Let's talk. If I wanna get the type, close this. Type inside what? Inside inside so many things. Okay, Control W. So what I have to do, I have to go to my front end, then lib, then peer manager. Inside peer manager, what I'm looking for the types. What are the types? RTP senders, RTP sender. This is the type. Let me have it side by side so that whenever I need the type, I know what kind of type do I need to have. RTP sender. This is the type. Same over here. Video RTP sender. Again, I will have to remember these types next time onwards. Otherwise, RTP senders. How long will I look for them? Okay, this thing is done. Apart from this particular thing, this is the interface. And okay, what all do I need to have? I have my peer connection. I have my RTP senders. I need to have my remote streams over here. So const remote streams. What will this remote stream contain? This will contain the remote streams, as simple as that. Remote streams. Again, this is gonna be an object. Again, I need to have the type here. The remote streams. And as for this type, I will have to create the type over here. Interface, remote streams, just like this. Again, as usual, it will contain the ID. That's gonna be nothing but a string, and then it will have the stream. Stream, media stream. Any problem? I mean, even if that is a remote stream, that is a media stream at the end of the day. And once I got the stream, congratulations, you are done. Ultimately, yeah, this is it. Okay, what is the next thing? Next thing is that I will have to create a function here, and function will be function like this, create peer connection. I will be getting my ID of, not my ID, the ID of that particular user over here, and real peer connection creation will start from here. Okay, let's create the peer connection. So const pc is gonna be equals to new peer connection. Are nahi baba, new. How do we create the peer connection? New peer create peer connection. No yaar, don't know how many things I'll have to search. How to create a peer connection, creating peer connection, creating peer connection. No, no, nope. How can I make a browser? Let's say this 14 years ago. Amazing. Nope, this not. Create a PC RTCP peer connection. So I think I need to call what? RTCP peer connection. Okay, so new RTC peer connection. This is how it's gonna be created. But turns out this is not enough because I need to have some configuration. What is that configuration be like? Const peer or configuration, and okay, I don't remember it. Peer connection configuration. I'm not gonna be taking the help of AI directly. That's not good thing at all. RDC peer connection web RDC tutorial. It's better to just simply go through the. Yeah, this is what I wanted. So new RDCP peer connection, RDC configure. So I need to have I servers. Inside those I servers, I will have an array. Inside the array, I will have objects. Those objects will contain the URLs. Okay, let's do that. So by the way, RTC or RTC configure, just like this. Coming back to this, what I forgotten, I servers. अरे भाई ऐसे नहीं I servers, and when it comes to those, that's gonna be an array. Inside that array, I mean there are gonna be objects. Those objects will have the URLs property, and then I will have to set the URL. Am I right? Let's see. I servers, an array, then object, URLs, and then proper instance servers. And what is happening here? After that, peer connection is created. Peer connection, create offer, do this. I mean multiple things. But okay, never mind. We are not gonna be going there. So RTC config in this much is done. I need to have instance servers. Free instance servers list. Public instance servers list. Click on this. Now these are the instance servers that you have. Let me get them some. Let me get some of them from the Google side. So these are the ones from the Google side. Copy all of them. Control C. I'm gonna be having the instance servers from the Google side. Paste them here. I'm gonna be getting all of them. I'm gonna be making a list of all the servers here. Why not? This is also one of them, and one was at the top. I mean, even if you have one, that's gonna be enough. It's not like you have to have all of them, but I'm just making the list. So these are the instance servers from the Google side. Again, they are free, don't worry. You have to just simply specify the URLs over here one by one. So this is the done. Similarly, no, there is a better way. What is the better way? I mean, it will work. It's not like it will not work. But RTC configure for peer connection. Set configuration with web. Set configuration. Yeah, here we are. I servers, URLs, username. This is the only way. Is there any another way? Getting started with peer connections. RDCP configuration. Where is this configuration? I servers. Oh, bro, I have to enter the URL in this way. There was another way. I've forgotten. But okay, never mind. This is the only way that's mentioned everywhere. So I'm gonna be going with this. So what am I gonna be doing? I will have few more URLs here. URLs just like this. Copy, one of them has been copied, so this one is done, right? Yeah, get rid of this. Then I have this one, copy it again. Why am I doing it? Because I have to do it. Not I have to do it, because I want to maintain the list of all the servers. This is not required. Even if you have two, that's more than enough. They will do their job. But me, okay, I'm gonna be having all of them, and it doesn't matter if you have them or not. Like, you must have them at least one or two, but if you have them all of them here, that hardly matters. Control X. So normal one, अरे भाई 1 1 हो गया, इसको नहीं चलाते. This is gonna be 3, इसको copy paste करते हैं. This is gonna be 4 and done. So ultimately these are the external servers from which side? These are the external servers from the Google side. Coming back to this, once I have this, I already have my ID. Then what will I do? Peer connections ID is gonna be equals to, oh bhai, this PC. Okay, that's great. So ultimately I have saved my peer connection as well. What is the next thing? On this peer connection object, I will be listing some of the events. First one is on negotiation needed. Will I get the event here? No, I don't need the event. It's gonna be just a normal function. Then PC dot on track. I need to have it at last. On ICE candidate. I have explained the whole flow. I'll be explaining it again. Don't worry. This thing is done. And then PC dot on track. I don't need to event. I need the event here. Event. Okay, this thing is done. If you're wondering what are you doing here, it's pretty simple. Not pretty simple. I need to have one more thing here. As soon as I created, okay, let's have a look at the flow. What is the flow? I created it earlier. Erasure. Utri. Finally, WebRTC is here. WebRTC flow. I created it earlier. How many things we have done, and it has been created by me. You must have seen me creating. Okay, by the way, coming back to this, how many things we have done? First of all, there are two people. The first one is the host. The second one is the normal participant. The host actually tries to join the meeting. It sends us to connect event to the signaling server. The server receives the request. The server checks, okay, you are the first person. You are gonna be becoming the host. So that particular person becomes the host, and the job gets done. Then what happens? Then another user comes, and that person tries to join the meeting. So that person will send the ask to connect request, and then the request will go to the signaling server. Signaling server will forward the request to the host, and host can now allow or deny the request. And if the host will send the grant permission event to the signaling server. Now signaling server check whether the host actually allowed or the host denied. If the host denied, so deny join permission will be sent to the another person, and the person will be redirected to the home screen, and socket will be disconnected. If the host actually allows this, in this case, that new participant will be informed about others, and others are going to be informed about that new participant. And then over here we have to create the peer connection. We have done this part. So this whole part of connecting the people, we have gone through it. Okay, now new participant got informed about others, and others got informed about new participants. We are focusing on this particular section right now. When others are getting informed about the new participant, at that time we have to create the peer connection. The question is, how is the peer connection created? So let's come back here. If you want to create the peer connection, at that time you need to call new RTCP peer connection. Of course, you will have some configuration over here, and done. Not only that, you will listen some of the events. First one is the PC on track. This is the event, and then PC on ICE candidate, and then PC on negotiation needed. Let's talk about them one by one. So what they do? So ultimately all the three events we have here. On negotiation needed. On negotiation needed simply tells if something changes in the peer connection, at that time I will get trigger. Obvious, simple. On negotiation needed, something changed. Now you need to negotiate again. You need to fix the things again. You need to I'm not fix the things, but ultimately you need to negotiate again. Ultimately you need to negotiate in the sense create the offer again, send the offer again, something changed in the peer connection. Now this particular event will be triggered so that you will negotiate in the sense, now you will create the offer, send the offer to the other peer so that other person can know that okay, this has changed and now you have to make changes and all, something like that. But in simple words, if something changes in the peer connection, this particular event will be triggered on ICE candidate. What are the ICE candidates? ICE candidates are nothing but paths, nothing but routes to connect it to the other peer, a way through which other person can connect it to you. So what happens? Your browser generates the ICE candidates. How will it generate? Forget about that. But when your browser generates the ICE candidate, so using this on ICE candidate event, this event gets triggered and you get the ICE candidate over here. Why do you need to get the ICE candidates? So that you can send those ICE candidates to the other person, and once that person receives the ICE candidates, now once both of you have the ICE candidates of each other, you can connect. Because what does this ICE candidate contain? This ICE candidate contains your public IP address, public port, in some cases private IP address, private port, and some other information. What are those? Go and dive deep into that. Overall, I told you this much. What is this on track? This on tracks once the peer connection. These two things happens before getting the peer connection established. So on negotiation ended, if there's anything change in the peer connection, this will trigger. On ICE candidate, this will trigger when your browser generates the ICE candidate. What are ICE candidates? It is some kind of data that is sent to the other peer. Why do we need to send? So that other peer knows about you, other peer knows about your IP address so that it can connect it to you. So that is it. Who generates it? Your browser generates it. How it generates it? When it gets generated, when everything starts, we'll talk about it. Then PC on track, when does this get triggered? When two peer connections are ready, established, connected, two peers are connected. At that time, one peer will send some track, some stream, some video tracks, some audio tracks to the other peer, and when those tracks reaches to the other peer receives them. At that time, on track will get triggered. As simple as that. Again, why does it need to get triggered? If it doesn't get triggered, how will you get to know about the tracks sent by other peer? So if the tracks are sent to you, you should be informed, and this particular event will be informing you. And what will you do when informed? Nothing. Set it to the video element, and the job is done. I hope it is clear. Okay, so let's continue from here on. But before even that, let's do one thing. By default, it's gonna be like this. Should I do it like this or not? Yeah, let's do it like this. At the end of the day, from my side, what will I be doing? From my side, I will be, because there are gonna be two options. There's gonna be the audio option, there's gonna be the video option. And once I have these options, then what I want to do, I want to directly set it to the peer connection. But they are gonna be disabled. It's not like by default my camera is going to be enabled. No, it's not like that. I will get these tracks, I will set it to peer connection, okay, but I will disable them for now. Why do I need to disable them? So that when I click on video icon, at that time my video should be getting enabled. But by default, I will say that I will send you audio and video. They are disabled, that is okay, but later I will enable it. But keep in mind that I will be sending you these. Okay, you will be sending, but before sending you should have them, right? And then you will be, even if you have a look over here, what am I saying? Create the, coming back to this, you have to create the peer connection, and then you have to add the tracks. First of all, from the local stream you have to get the tracks, and once you got the track, you have to add it to the peer connection. Once you have added it to the peer connection, then you will be getting the audio track or the video track. Then you have to set it to the RTP senders, and the job will be done. But the thing is that, how will you get the track? Even before that, how will you get the stream? That is the local stream. That simply means you can get it easily. So let's do one thing. Let's go to the media manager. Right now here we need the local stream. Local stream. We need the local stream. Why? So that we can get the track. Why do we need the track? So that we can get the audio or video track. Why do we need to set them here? So that whenever the connection gets established, the other person knows that I'm gonna be sending audio and video track. And are they gonna be enabled by default? No, I'm gonna be disabling them by default. But ultimately, I need to set the tracks, right? Yeah, that's right. Question: how will I get the local stream? That is the first thing. So let me go to the media manager. Again, I have different files: peer manager, media manager. They are nothing but files, and you can keep everything at one place. But in this way, things are not gonna be organized. And because of that thing, I'm just simply keeping them at different places. By the way, what will I be doing here? In here, first of all I will have my local stream. Okay, and local stream. What is gonna be the type of the local stream? First of all, it will be media stream, just like this. So let me make it a letter, just like this. Okay, so I will have my local stream. Anything else apart from local stream? I will have my letter screen stream, because of course I will be sharing my screen as well, right? So screen stream. So this is for the screen stream. By default they are undefined by default. Should I do it like this? I don't have them like by default, so yeah, they need to be like this only. Okay, what else? So local stream, screen stream. I mean अभी के लिए तो इतना ही. Later we'll see what we do. Okay, this much we've done. What is the next thing? I have to create a function, and I will have to export that function. Export function get local stream. This is gonna be the function. What is the job of this function? Getting the local stream. How will you get the local stream? Great job. Const, again no const, just local stream, because I already have it here. Local stream is gonna be equals to what? Navigator. There is a object called navigator dot media devices dot, again I don't remember them. When I see them then I remember them. Get user media. I want to get the user media, so navigator dot media devices dot get user media, and when I get the user media, I'm gonna be allowing audio is gonna be true and video is gonna be true. So I'm just simply saying, bro, I'm gonna be allowing both of them. Let me make it async so that I can make it await, and the job is done. Okay, so what am I doing here? This is just a local stream that I got locally. And how do we get navigator media devices? I want to have the media devices. What is that gonna be? User media. I want audio, I want video. By default I will be disabling them. The question is, how can I disable them? So you cannot disable the stream. You can disable the tracks that you get from the stream. So how will I get the tracks? That is a good question. So local stream dot get tracks. Here I'm gonna be getting the tracks. This get tracks return an array. So ultimately what happens? Local stream dot get tracks will return you array of tracks. What those tracks can be? That can be audio track as well, that can be video track as well, because you are enabling both of them. So what I want to disable that by default, even though I'm adding it, but I want to disable it so that when I join the meeting my camera is not on by default. When I click on the camera button, at that time that gets on. Okay, so local stream get tracks for each, because this is an array, so I'm gonna be looping through it. What will I get? I will get the tracks. Those tracks can be audio track as well as the video track. By the way, track dot stop. So I'm gonna be stopping those tracks. Is that really so? Just a minute, let me think. Stopping the track will stop it directly. No, this is not what I want to do. Look, what does this stop do? Stop means you are just simply stopping the track. So I want to send it, right? I don't want to stop it. So this is not the right place to call it. Rather, when I'm creating the senders, inside the sender I have to just disable it. Okay, let me not do it right now. This is fine. And let me just simply return a local stream, just like this. Yeah, simple. If I don't have the local stream, if not local stream, CLG, no local stream is not available, just like this, and I'm gonna be returning from here, just like this. This is how I'm gonna be going ahead. That's pretty simple. I'm just simply getting the local stream. The most important thing, local stream is actually saved here. That is the important thing. By the way, get local stream. One more thing, I will check that if I don't have the local stream, only in that case I will be creating that, otherwise not. Simple. First of all, I will check that I don't have the local stream because I'm saving it globally over here. So if I don't have the local stream, only in that case I will be creating it. Otherwise, if I already have that, and I will be checking and all, and I will just simply return from here. That's simple, right? By the way, I don't even need to have it now. Okay, this is how it's gonna. I can have it by the way. Why not? Over here it's being created, then it should be there by default. So yeah, this is done. So it's pretty simple. Get local stream will simply return me my local stream. Okay, can I call it there? Yeah, I think so. And one more thing I can do here. What is that? Media manager. I got my local stream. Let me get the tracks from here. Original tracks. Original video track. I'm gonna be replacing it with that. I have this. Okay, once I have this, what will I be doing next? I need to have my original video track. Why do I need to have original video track? So that when I'm actually sharing the screen, at that time I'm able to just replace the video track and I'm able to add the screen track. That is okay. And after the screen sharing, I'm able to get the original video track back. Okay, as I have this local stream over here, how will I get the original video track? Because if I call stream.getTracks, I can get the video track. Got it. So if I have the local stream, in that case local stream.get video tracks, I got my video tracks, it will return me the video track. And once I got the video track, let me create another object called let me keep it here. Why do I need it? I will be telling you later. Like when I actually use this, you will know. Original video track, and this is gonna be what? Media track. What is the type of this media stream track? Hopefully this type is the biggest problem, but okay. I got the video track, and once I got the video track, I'm gonna be setting it to the original video track, just like this. Why do media track stream is missing the following properties. The media stream track content header, enable header, get video tracks. I have the video tracks. What is the type of this original video track? Track, media track, media stream track. This is missing the following properties. What is the type of original video track? Sorry, I'm gonna be having a look at this, otherwise I'll keep wondering. Media stream. Alright, let's go to the top directly. Can't I go to the top directly? Yeah, I can. And then media stream track, or it can be done. I have that only, media stream track, but what is the issue then? Let's see. If I keep it equals to none, in that case, just a sec, coming back to this one. How am I setting the value? Register stream update, not that. Create connection, not that. Local media stream. Coming back to this one. Media stream track. I'm having a look at this because I'm not sure about the type. Sorry for that. And I'm actually nicely zeroth. Sorry. Okay. What was I doing here? I should not have even had a look at the code, but it's okay. Sometimes that's fine. There is a mistake that I'm making here, and that is the most common mistake. And what is that? That is when I'm getting my media stream here. Oh, let's talk. I don't need to have this. Okay, here we are. So when I'm getting the local media stream over here, I'm saying get tracks. Keep in mind, this always returns what? Array. So the get video track method media stream interface returns a sequence of media stream tracks objects representing the video tracks in this stream. So ultimately it returns sequence of media stream tracks objects. Sequence in the sense that is definitely the returned value is nothing but not media stream track, rather the array of that. And this error was telling me exactly the same. Media stream track is missing the following. So ultimately what is the type of this? The type of this media stream track array. And what I want the track at the 0th index. Just like this. And again, now what is the problem? Now media track or undefined is not assignable to media track or null. So okay, that's okay, that's okay. Let me remove it now. And what is the problem right now? Media track stream or undefined. So ultimately the value I'm getting that can be undefined or that can be media track stream. So in that case, the values that I'm actually getting here, let me make them undefined. Will it be problematic? Now the is gone. Okay, by default they can be undefined as well, not really big problem. This is how I'm gonna be going ahead. Okay, what can be the next thing? It's pretty simple by the way so far. When I call this get local media stream, I should be getting my local media stream, so I can be back again. Why do I need to have this? I will be telling you later, not now. Coming back to this, normal, I'm creating the peer connection over here. Let me just simply import it. Once this is done, close this. Coming back to this, so when I'm creating the peer connection, even before that, over here, or after that or before that, doesn't really matter, maybe somewhere here, once I have the peer connection, I have saved the peer connection as well. So pc dot, first of all, I want to get the local stream here. So local stream is gonna be equals to what? Local stream is gonna be equals to get a local stream. Again, we are getting it, we have defined this function. Once I got the local stream, then what? I have to get the tracks. Okay, I will get the track, but what? Once I get the track, once I get the track, after that I have to set them. I have to set them in the RTP senders, and that can be audio track as well as the video track. So if I'm not wrong, first of all, let's get the tracks from the local stream. So local stream dot what is the return value of this? Promise media stream. Sorry for that. Let's simply await it. I'll have to make it a sync. Now this is fine. Now this local stream does have it should be giving me the suggestions. Local stream dot, yeah. So get tracks rather. So now I will be getting all the tracks. Great. Once I'm getting all the tracks, so for each I will be getting the track over here. Now what will I do? Once this much has happened, so after that I have the track, so I will be adding the track to the peer connection. So peer connection dot add track, and I will be adding this particular tag, and this will be done. And from here I will be getting the sender. So const I'm gonna be getting the sender. This is what is happening right now, and that is okay. Just pretty simple thing. But I have to assign the value of that. But before that, I need to know the type of the track, whether this type is audio or the video. So if t dot how will I know the type of the track? So this is definitely is the track. Control D, track. Once I got the track, then I need to know the type of the track. So once it comes to knowing the type of the track, so clg track dot kind, yeah. So I will be getting the kind, and what will I say? That kind can be actually audio or video. So if track dot kind, if that's triple equals to audio, then do this. Let me use a switch statement over here, or even better, I can do one thing. I have to save it inside RTP senders, right? So let me do one thing. I already have the ID here. So RTP senders, they will have the ID. So yeah, object is created. Inside that they will have some track, audio or video. So RTP senders returns me the object. So ultimately RTP senders returns me the object with the help of the ID, and inside that particular object I have either the audio or the video. Coming back to this particular thing, that the kind can actually be audio or video. So I can just simply say that track dot kind will be equals to what? Will be equals to pc dot add track, and that is it. Now what is the, again simple, the RTP sender ID just simply creates that. And one more thing I can check, that RTP senders and ID. This is fine. If it is already there, then that's okay. If it is not there, it will be created, so not really big problem. And what is the problem? The problem is that no index signature with the parameter of string was found on the type audio and video. Okay, it is just simply saying that, right? Parameter of type string was found on the type audio and the video. Okay, so I have to maybe specify here that the track kind that I'm getting, that can be either audio or the video. Fine. Okay, what is the problem? Is possibly null. RTP sender is possibly null. So if not I'm creating that, right? And once I'm creating that, so let me do one thing. Once RTP sender is gonna be equals to this. Once I have this, now it is saying object is undefined, possibly undefined. So ultimately RTP sender is possibly undefined. So let me do it like this. So RTP sender, this whole object is possibly undefined. That is the problem. Where is that? This is the one. So in that case, if not RTP senders, in that case it will return it. Still problematic. Object is undefined. What is the issue? Just a sec. This is the RTP sender that I have. Okay, and this will have this will be type of this. I'm even giving it the types, and when it comes to this RTP senders, so they will have the ID, and inside that they can have the audio and the video. Again, they are gonna be kind of the optional ones, by the way, and ID is definitely gonna be there. And once the ID is there, so it is just simply saying me that object is possibly undefined. So RTP senders and ID that I'm actually getting, that particular object is possibly undefined. Okay, so what if I make sure that it does exist, then it will not throw the error. But this way don't like that. So what will I do? Let me get rid of this. Const RTP sender, not like this, yeah. RTP sender, once I got the sender, if not RTP sender, return. And as for this one, RTP sender dot this, RTP sender, and this. Alrighty, so fine. Coming back to this one, I'm just simply first of all creating the RTP sender with that particular ID, and once that particular thing is created, then I'm checking whether that actually, if that does not exist, I'm returning from here. If that does exist, in that case RTP sender track dot kind, that kind can be actually audio or the video, so the value will be set there automatically. And as per the type, I mean, if the track kind is the audio, I will be adding the audio track. If that track kind is the video, I will be adding the video track. So this is how it's gonna be going ahead. Alrighty, so this much I've done, but this is not over yet. Why? I have added the tracks, that's great, but now I have the RTP sender. That's a good thing that I have that, and once I have that, I'm gonna be adding all the tracks. So I have added all the tracks, and not just adding the track, I have RTP sender, right, dot audio dot enable is gonna be false. Any problem? Enable does not exist on that. Audio is nothing but the audio sender. So once I have the audio sender, I should be able enable and disable. So RTP sender dot audio dot what. I will be able to replace the track. That's great. Can't I disable it? Whoa, okay, I can't disable it here. So I can definitely replace the track from here, that is possible, but disabling it from here, that is not possible. So I can only do this much, but I still have to disable it. So if I go here and I got my local stream over here, once I got my local stream, I'm returning from here. Here if I try to disable it as well, that I have my local stream, get tracks, I will be getting all the tracks. Once I get all the tracks, I will be looping through them and I will be getting their track. Once I get the track, so track dot getting the property here. You can stop the track, stop, yeah, you are getting that, and you can disable, enable, disable from here. Enable false. So what am I doing? First of all, I am getting my local stream. Once I got my local stream, after that I'm checking whether that exists or not, and after that I'm just getting the video track. Why am I getting the video track? So that in future when I'm actually sharing the stream, at that time I can use this. Okay, how will it be used? Don't worry. And then I'm actually disabling all the tracks. So local stream get tracks, from the get tracks I will get an array. That array will contain audio track as well as the video track for each track, and I'm track dot enabled is gonna be false. Why? I'm disabling the tracks. It does not mean I'm not adding the tracks. Those tracks are added. I have the tracks, but the track is disabled. So it's like, first of all, you don't have track at all. Second thing, you have the track, but the track is disabled. So I want to have the track so that I can send it to the other peer, so that other peer can know that okay, I will be sending audio and video track, but the track will be disabled. By turning on the camera, I can enable it again. By turning off the camera, I can disable it again, and this is how it will be going ahead. So just this is how the things are gonna be going on. Okay, by the way, this is done. What is the next thing that I can do? From here, I'm getting the track over here. Once I got the track over here, local stream, then what am I doing? From the local stream, I'm getting all the tracks again. Once I'm getting all the tracks again, this can be audio track as well as the video track. So what am I doing? First of all, I'm making sure that RTP sender does exist. After that, RTP sender, ultimately this will contain audio or the video. If you actually have a look at this, so the type of this RTP sender is what? This type of this RTP sender is that, first of all, you will have the ID. Just below that, you will have an object. That object may have the audio, may have the video, may have the both. And that's what I'm doing over here. That okay, I got the RTP sender. Then track.kind can be audio as the video. This is the type in, like I'm simply giving the type, the kind that I'm actually getting, that can be audio or the video. If the type is the audio, then RTP sender will have the audio track or audio sender, because pc.add track returns a sender. Okay, so whenever you are adding a track, you get a sender, and that particular sender will be assigned over here. If that is a video, you will have the video sender, and this is how things are done. So what we've done, we got the local stream, we got the tracks, we got the audio or the video track, we set them, we disabled them. We disabled them long time ago. Okay, that's great. So this much we have done. What is the next thing? We have done this much, right? So if we go back to our flow, so we created the RTP sender, we got the local stream, we got the tracks. Once we got the tracks, so we added the tracks to the peer connection. Once the track got added to the peer connection, then what happened? If that was the audio track, we got the audio sender. If that was the video track, we got the video sender. And once we got the sender, we added the sender to the RTP senders. Amazing job. And what is the RTP sender? That's nothing but an object. So this much we have done. Amazing. What is the next thing? The next thing is that if you actually remembered what we did here, we added a track to our peer connection. Amazing. What I said earlier, whenever something changes in the peer connection, on negotiation event gets triggered. As simple as that. What you are doing, you are adding a track to the peer connection. What is the peer connection? This is just kind of an object. And whenever you change something, what you did, you just changed the add track right now. So the value inside that got changed. As soon as the value inside that got changed, this pc.on negotiation needed event will be triggered. That means whatever you write here, that will be processed here after that. As simple as that. Okay, now what do we need to do here? What we've done, we have added the track. As soon as we added the track, this particular event got triggered. As soon as this event got triggered, so now what is the job? You have to somehow tell the other user about you simple, and know about the other user. You have to know about the other user and you have to tell the other user about you. That simply means you have to send the offer from your side. Offer will other user will get the offer. Once the other user gets the offer, other user will send you the answer, and again once the other user gets the offer, it will set the offer on its side, and then other user will create the answer, will send the answer back, and you will be simply setting the answer. So this way, what is the offer? Offer contains information about you. So you will create an offer that will contain the information about you. That offer will be sent to the other person. That other person will receive the offer, and then having the offer, that person will know, okay, this is who you are and this is kind of data you are sending. Mainly offer receives the kind of data. So when you create the offer, that contains the media info that you are going to be sending. You will be sending it to the other peer will receive it. It will know, okay, you are going to be sending audio, video, and all these types of things. Then another peer will create the answer. What is the answer? Nothing, just like offer. Answer creates the media information of that another peer. You will receive the answer. Now you know what kind of data you will be getting. Other person knows what kind of data that other person will be getting, and the job is done. And there is one more thing. Now you know about the data, what kind of data you will be getting. How about how you will be connecting? Over there's something called ICE candidate. So ICE candidates are mainly going to be used over there. But first of all, let's simply create the offer. Const offer is going to be equals to pc dot create, not answer, create offer, and that is it. pc dot create offer. Offer is going to be created. Once the offer is created, then pc dot set local description. Because you have just created the offer, you haven't even set the offer to the local description. So there are two things: local description. There is something called local description, and there is something called remote description. Okay, this is again you can call it using PC object. So the main top level thing, you have this peer connection. Inside that peer connection, you can set the local description, you can set the remote description. What are they? The way we have offer in answer. What is the offer? Contains the information about you, as simple as that. So your media info, right? Again, you can know more about it. You can even log this value. And then what is the answer? Another user's media info. As again, it contains more things. It's not like it only contains the media info, it contains more. But overall, this. And what is the local description? Local description will contain your info, local info, and remote description will contain remote info, remote. Again, things are clear, right? So once you created your offer, you have your local info, so you will be setting it to the peer connection, as simple as that. Once you receive the answer from the other peer, that peer then you will be setting the remote description. So remote description will have the information provided by the remote peer, another peer that is remotely that is created remotely and all, something like that. We will be going through it. Coming back to this, so set local peer connection. It is saying that promise. Let me await it. Once awaited, let me make it async, just like this. So okay, what is happening here? Simple. You have created the offer, you have set the local description. Once this is done, coming back to the flow, first of all, we have done this much. We have created the RTCP, got the local stream, got the tracks, added the track to the peer connection, then we got the audio or the video sender, and then added the sender to the RTP sender. What happened? As soon as we changed the value, we added the tracks to the RTP sender, what will happen? This particular event will trigger, on negotiation event gets triggered. And what happens in here, as soon as this gets triggered, so you create the offer, you set the local description, and the important thing, as soon as you set the local description, ICE gathering process starts. What happens here? ICE gathering process, in the sense your browser will start gathering the ICE candidates. What are the ICE candidates? ICE candidates contain the information about you, your IP address, your public IP, private IP, public port, private port. Why do you need to have them? So that you know about yourself, ultimately, first of all, this thing. And the second thing is that you can send the ICE candidates to the other peer. Another person will receive those ICE candidates, and you will receive the ICE candidate of the other person, another peer. Then what will happen? Both of you will know about the IP addresses of each other. And once you know the IP address, once you know the port number, you can connect it to that particular person, as simple as that. I hope it makes sense. Okay, so ICE gathering process starts here. So what is the flow? On negotiation event will trigger. You will create the offer. You will set the offer. And as soon as you set the offer, ice gathering process will start. Your browser will start gathering the ice candidates and all. And once your browser gathers the ice candidates, that's it, the job is done. Then you have to send it to the other PM. But remember what happens here. First you get the offer, that can be offer or the answer, depends. Then you just set. So first of all get, then set, then ice candidates. So this ice candidate gathering stuff or setting stuff will be at the third place always. So here it happens at the third number, later it will be happening at the third number. Whenever it happens, I will be letting you know. So ultimately overall flow is here, simple PC. And one more thing, if there is a new user, if new user joins your room, so you should be creating your room, not the, sorry, you should be creating the offer. There can be question ki who will create the offer, because there can be multiple users, right? So at the end of the day, there are two things, offer and answer. But somebody is somebody needs to take the initiative, right? Okay, I'm going to create the offer first, and then you will have to create the offer. So what happens, one user will create the offer, then that offer will be sent to the another person, that person will get the offer, that person will set the offer, then that person, once the offer, that person will create the answer, and once the answer is set, that person will create the answer, that person even will set the answer. These many things are gonna be happening, and once that person has set the answer, then that particular answer will be sent back to you, and then you will be getting the answer. So you will receive the answer over here, and you can just simply set the answer. But before that, bro, somebody needs to start it. Somebody needs to say that I am going to create the offer. Okay, so over here what is all logic? All logic is pretty simple, that you are the one who's already in the meeting. A new participant joins the meeting. So when a new participant joins the meeting, so that person will send you a request and all, then that is okay. But ultimately this new person joins the meeting. At that time you will be creating the offer. Okay, so the person who is already in the room, that person will be creating the offer, and that person will just simply send the offer to this. Then the new person will create the answer, and once he create the answer, you will be getting the answer from this new person. So this is the overall flow, as simple as that. That simply means if a new user joins the room, make sure that person cannot create the offer, because if here you are the one, here there is another person, new person that joins the room. Of course you created the offer as soon as the person joined the room, and if you are not stopping this person from creating the room, because this person will definitely create the peer connection. Once this person creates the peer connection, then what will happen, tracks will be added. Once the tracks are added, on negotiation this will run. Once this will runs, it will create the offer in the end. So ultimately what will happen, you created the offer, this person will also create the offer, both of you will send the offer to each other, and then there's gonna be offer conflict, because you cannot you created the offer, that is great, and then what happened, you will send your offer here, and that particular new participant will send the offer to you. But this participant was supposed to be sending the answer, right? So you should be getting the answer from this participant, and what happened, you got the offer, and then that's gonna be error. And that is why it needs to be clear who will create the offer. So what I will say here, over here, if I will check, if you are a new participant, you should not be able to create the offer, because I will create the offer, you will get the offer, then you will create the answer, and then I will get the answer. Okay, so what will I be checking? Somehow I will check whether you are the new participant or not. Okay, and if you actually checked it clearly here, so we are maintaining a state, we've been maintaining it since the beginning. We have something called newly joined participant. So the participant who just newly joined, we have it saved in our state. Amazing job. That simply means from here we can get the state, we can check. There are two things. There is something called there is something called current user, and there is something called newly joined user. So you have to check, the current user should never be equals to newly joined user, because for you are the current user and newly joined user is the other person. But for the other person, that person is the current user as well as that person is the newly joined user. So that person, in that case, if the current participant is equals to the newly joined participant, at that time, that person, that means that is a new person, and that person should not be able to create the offer. Why? We got it, ki offer conflict will happen. Coming back to this, again I'm not explaining it in detail, even it could have been explained quite in detail, I get it, but I'm sorry, because even I have to just simply finish it. And if I just start explaining exactly in detail depth, that's gonna be too much. So let's see, in future I may be even creating proper things on it, but for now let's simply get this project done. So ice gathering, what I have to check it over here, right? So what I mean, simple thing, I have to check if the current participant if that's triple equals current participant dot id, if that's triple equals to newly joined participant dot id. If that is so, return, as simple as that. But if that is so, I will return, that is okay. I will even have a log here, clg skip of for creation for newly joined participant, or skipping, just like this. But you need to have the current participant, you need to have the newly joined participant, and the good thing is that you have both of them. How will you get them? You have them in your state. And what is this? This is just a normal function. So for getting the state, const use meeting dot get state dot current user, current participant, and similarly use meeting dot get state. Again, I'm getting them one by one because I need to subscribe the state one at a time, so that if something changes in the current participant, only that particular gets changed. The whole state doesn't get changed, doesn't get reset, not even reset, re-render. So it's like if you are subscribing to one particular state, when that state changes, only that value will re-render. But if you are subscribing to the whole state at the same time, so everything will be re-rendered. So I hope you get that. By the way, if you are not getting that, then simply focus on the basics, and slowly you will get that. It's not that hard. Coming back to this one, I need to have a newly joined participant. Once I've done this much, const current participant is gonna be equals to this, const newly joined participant is gonna be equals to this. So I have both. I have newly joined participant, this. What is the problem? Is a possibly null. So if not current participant or not newly joined participant, if there is no current participant and there is no newly participant, will I just simply return from here? When do I have to create the offer? When there is a new participant joining the meeting, right? When a new participant has joined the meeting, at that time I have to create the offer. So yeah, return, that is fine. The spelling is wrong, copy, paste. So this much we've done, great job. What is the next thing that we have to do? And if current participant ID is equals to newly joined participant, that means new participant is trying to create the offer. That participant should not be able to create the offer. We have explained why. And once we've done this much, we have set the local description. As soon as the local description is set, then what will happen? As soon as the local description is set, ice gathering process will start. And let me show you the diagram. When you create the peer connection, you just do everything, and then peer connection, peer negotiation needed gets triggered. You create the offer, you set the local description, ice gathering process starts, and when ice gathering process starts, at that time the role of instance servers comes here. So they just get into the picture here. So what happens? Your browser starts gathering the ice gathering starts. As ice gathering, in the sense, it will gather the ice candidates. What are the ice candidates? They contain your public IP, private IP, all these things, so that other person can know about you. Okay. So when ice gathering process starts, at that time your browser needs to know your public IP, right? Your browser knows your private IP and private port. Why? Because look, if there is a top level router in the sense, the network comes to that particular router. That router is connected to many devices. Those many devices are being assigned private IP addresses by the router. If you know about the router and devices now, this will make sense definitely. So there is a top level router. That router gets the public IP. So once that router gets the public IP, and to that router your many devices are connected. Maybe your laptop is connected to the router, your PC is connected to the router, your mobile is connected to the router. Your mobile, PC, laptop, they are getting private IP addresses from the router. They don't have their public IP address. Router has the public IP address, and if a browser is open on your PC, So how will your browser know your private IP address? Public IP address? Of course, it will not know. So what will it do? It will send a request to the stun server. So the stun servers don't do much. What happens from your browser? Ultimately, when the ice gathering process starts, a request will be sent to the stun servers. Whenever a server gets the request, so server will know, okay, what happens? What will happen? Your browser will send a request to the stun server. So the request will go to the router. From the router, the request will be forwarded to the stun server. So if a request is being sent by the browser, so no doubt the request will have to go through the router anyhow. And once the request goes through the router, so when the stun server receives the request, stun server will know that this request is coming from that particular router, and then stun server simply will know your public and IP and public port, and in the response they will be returning your public IP and public port, as simple as that. And the request will come to the router will forward it to the browser. Once the browser gets the request, browser will automatically get the IP and public IP and public port. Now browser knows your public IP and public port. By default, browser does not know, so it will take the help of stun servers. It will send a request and it will tell that, okay, stun server, tell me who I am, what is my public IP and port. Stun server will tell them, stun server will send the request, it will get that, it will create the ICE candidates. Again, those ICE candidates may be using TCP protocol or maybe using UDP protocol, transmitter, forget about the full form. I don't remember. What is the full form? User data, forget about it. Let me know it. TCP full form. Transmission control protocol and user datagram protocol, if I'm not wrong. UDP protocol. User datagram protocol. Yeah, I was right. Yeah, great. Sometimes I happen to be right by mistake. Mistakenly, not mistakenly, but yeah, coincidentally. Coming back to this. So this thing is done. So it's pretty simple. This got triggered, created the offer, set the local description. Browser started gathering the ICE candidates. Browser will send a request to the stun server telling that, tell me who I am, what is my public IP and all. Then it will receive the response. Once it receives the response, it knows the public address. Then it will create the ICE candidates. And once the ICE candidates are created, then what happens? Once the ICE candidates are created, once the browser has created the ICE candidates, pc.on ICE candidate will be triggered. And when it gets triggered, from here, if you just say event.candidate, you will be getting the candidate. And now what can you do? You can send the candidate to the other peer. Okay, receive the candidate from my side. Similarly, over here, once you created the offer over here, created the offer, set the local description. Now you can send the offer to the other peer. So ultimately, what will you be doing? Pretty simple thing. Coming back to this main thing. Coming back to the starting point, when you try to join the meeting and host actually allows you to join the meeting, so what happens? Others are informed about you are informed about others. We are mainly talking about this particular part. When others are informed about you, at that time what you are doing, at that time you are setting the state and all, that is okay. You are creating the peer connection. Once you are creating the peer connection, so ultimately what happened? Somehow, some way or the other, you created the offer, you created the ICE candidates, you got the ICE candidates. When you created the offer, you set the local description. After that, browser started creating the ICE candidates. Then once the ICE candidates are created, you started getting the ICE candidates here on this particular event. And after that, what are you gonna be doing? At the end of the day, you have these two things. You have your offer, you have ICE candidates. You will be sending the offer to the signaling server. Signaling server will forward the ICE candidate and offer to the other peer in the end. This is what happened. And the other participant has to do the same thing. If you understood this much, things are gonna be easy peasy. Okay, so it's as simple as that. You created peer connection. Why did you create the peer connection? So that you can connect it to a new person. And again, it's hard. It's not like easy peasy thing, but once you understood, it will completely make sense. So yeah, if you want to have a command over it, you will have to just struggle a lot. I actually struggle a lot. The main reason behind creating this whole diagram was to understand what is the real flow, what happens when I need to do this and when I don't need to do this. So it took me I struggled quite a lot to just simply understand this stuff. But overall, it is not even that difficult. By the way, coming back to this particular point, I have to send the ICE candidate and offer. But let me work on the logic part. Set the local description. Okay, once the local description is set, ICE gathering process will start. Once the ICE gathering process starts, again from here, send the offer to the other peer. And apart from this particular thing, once the ice gathering process starts, the request will be sent to the instance server automatically from the browser side. If you remembered, here we have just simply specified instance servers in the configuration. They will just do the job, and once this is done, then inside this PC on ice candidate will be triggered. That simply means I got the event. So event dot ice candidate, so event dot candidate, if that exists, then what I have to do, send the candidate to the other peer. And there could be there can be more than one peers. There are definitely gonna be more than one candidates, I mean. So there can be one candidate using TCP protocol, there can be one candidate using UDP protocol, there can be one candidate using your host that can be generated by the host, and there can be one that will be generated using the public and private addresses got from instance server side. So yeah, there can be many of them. You can even check them, you can log the values. I'm not gonna be logging them because it's gonna take a lot of time then making things. Ultimately I can just I can just simply explain them from the upper level. But yeah, if I'm talking about the event, this event actually contains the ice candidate. You can log it, you can check it and see how the things work. But we have two things here. We created the offer, we have to send the offer to the other peer. To the other peer in the sense, if I am creating the offer, I have to send it to everybody. And then once I got the ice candidates, I have to send it to the other peers as well. That's great. So now what is the job? I have to send it to the signaling server. Signaling server will forward it to the other peers. Okay, so this is how it's gonna be going on. Other peers in the sense, except me. Just a sec. Other peer joined it. When the other peer joins it, at the time I created the offer, I send it to the signaling server. Now from the signaling server side, I need to send this to all the peers, or to only that person. Good question. Once I created the offer, okay, I created the offer for whom? Just remember this thing. This particular offer or this particular ice candidate was created for whom? This and this, they were created for the user that has this particular user ID. This is not my user ID, this is the user ID of the participant who actually joined. That simply means I have to send this particular offer as well as the ice candidate to this particular ID. That simply means it needs to be sent to the user who actually joined the room. It needs to be sent to the user for whom this peer connection has been created. So it's not like I will be sending the offer to everybody. I will be sending the offer to the user containing this particular connection ID. This is how it's gonna be going on. Alrighty, how long has it been anyway? I didn't even check. 2 hours. Amazing. Let me continue. Let me write some more logic and then we'll call it. Okay. So how do we send the offer? We already have the ID. Once we have the ID, we have to just simply send the message to the signaling server, to the socket server containing this ID. Then signaling server will just simply send the whole message to the ID. As simple as that. For this thing, let me create a common function. Would be better if I actually create a common function. Let me create it here, and that's gonna be related to the HTTP process. So what should be the name of this function? Send it to the signaling server. Okay, so function send to signaling server. I mean normal. What will it do? It will take two things. First of all, it will take your message. What is the message that I have to send to the signaling server, and to whom this message needs to be sent. So that's gonna be string. And as for the message, this message this message will have many types. Yeah, that's gonna be crazy. Let me make the message to a string again. Why? The message will be stringified at the end of the day. So I will be stringifying the message from there only. So message itself is gonna be string, and 2 is also gonna be string. Why the message will be string? Because I will be stringifying the message. In socket.io you don't need to do it, but in WebSocket you need to stringify the message. Call json.stringify and then that will be stringified. Hopefully this will not problematic. Then what will happen? Interesting question. I need to get the socket. So const WebSocket is gonna be equals to get socket again, not get cookie, yeah. Get ws connection. Again, this is the connection of the user. So if you actually have a look over here, when I created the WebSocket connection for the first time, I just saved it globally so that whenever I need, I can just simply get it. Great job. Coming back to this, I got the WebSocket. What I have to do? WebSocket.send, and great job. I have my message and two. This message there is a problem. Usually what should happen, this message itself should contain both the things, but right now what is happening, I am sending one more extra thing. So this two will be added in the message also. Usually what do you have in the message? Usually here there is a message object. It's just like this. You just have a label. Again, this time label is gonna be different. This time label is gonna be WebRTC process. Got it? So keep that particular thing in mind. Apart from this particular thing, then you have data. Inside the data, you have the type. Again, what kind of type here it is? I mean, any type, for example. And then you have the payload. Okay, but we have to send the this as well. So we are gonna be sending a label, data, and lastly we are gonna add one more thing. That's gonna be 2. Will this be fine? Will it be okay sending here 2? And then whenever I'm parsing the message, from the message I can get this 2 as well directly. Will not be bad thing either. Yeah, let's do it. So I will be just simply getting the, or I can do one thing. Okay, let's do it. I'm gonna be getting the message over here. That message is itself is going to be stringified, and once the message is stringified, I'm just gonna be sending the message from here. So this is the job of this particular thing. Okay, now over here this message will contain the 2 as well. Send a signaling server, copy this from here, paste this over here, and it needs to get the message. Simple. And this message itself needs to contain many things. So let me create it here. Const message is gonna be equals to what? Message is gonna, first of all, message will contain the label. So what is the label? Labels dot, let me import it from constants. This is a constant variable. This time it is gonna be WebRTC process. Okay, apart from this particular thing, it needs to have some data. What is going to be the data? Type. What is gonna be the type? Type is actually gonna be offer this time. Offer. How about let's name the type SDP process. Why? Otherwise I will have to create 3 functions, one for offer, one for answer, one for ice candidate. In this way I will have many things at the same time. So all of this is related to SDP process, so I'm gonna be naming it this SD types from constants variables. What all types I have these many types over here, and I'm gonna be creating one type that will be responsible for offer, but there's gonna be problem. Just a sec. The payload will contain the offer. Let me send it one by one. That doesn't really matter, but one by one I will have to create many functions here. That's gonna be problematic. So let me go here. I'm gonna be creating one more offer. I'm saying SDP process. So SDP process. SDP process will handle what? What is the form of SDP? I forgot the form. SDP full form in WebRTC. Session description protocol. So ultimately this is related to the, I mean offer, answer, and all these things are related to the here. Purpose negotiates the media capabilities between peers, browsers, devices to ensure they can communicate, acting, or whatever. I mean, you can just read through it. The important thing is that offer answer model. WebRTC uses an offer answer model where one peer sends SDP offer. So that is SDP offer, and the other responds with the SDP answer and all. So this is called SDP process, and that is why I'm naming it SDP process, nothing else. Okay. So why is the name of this SDP process? Because it will be what is the offer? Offer is nothing but the SDP offer. What is the answer? That is nothing but the SDP answer. Session description protocol, something like that. The full form is, that doesn't even matter. I don't even remember. Copy, paste. Okay, so this is gonna be the SDP process. Gonna be back over here. Over here, the types is gonna be what? The types is gonna be SDP process. I need to send the payload, and this payload will contain what? This payload will contain the offer this time. Any problem? No problem as such. Okay, and how will I be? I'm just thinking how will I handle it on the backend side. It would be better that if I send the type as well, type of this offer. So type is gonna be offer and offer. So using the type, I will be able to just simply check this thing out as well. But here I'm sending the type. This is the type of the whole data SDP process. This is the type of explicitly of that particular offer, but this is not even needed. Even without this, you can just simply go ahead. I will show you just with this particular offer how you can just simply handle this. Okay, so this particular thing is done, and after that you have to just stringify it. So json.stringify and message. This is not done yet. Over here you have to add one more thing, and that's gonna be to whom will you be sending? To this particular ID I will be sending. Simple. Label is this, data is this, to this particular person this offer needs to be sent. As simple as that. Okay, and then send it to signaling server. It will be sent to the signaling server. Now signaling server will receive it, and that's gonna be WebRTC process. So let's simply handle it on the server side. Okay, same here. Same will happen with this as well. Event.iceCandidate. So what will I be doing? Const message, and overall things are gonna be fine. I have to send the candidates to the other pair only. So let me copy it all. Let me paste it here. And what am I doing? I'm gonna send the message WebRTC process. Data is gonna be SDP process. Again, type is gonna be that. This time I will be sending what? I will be sending candidate. Candidate is gonna be equals to event.candidate. Again, simple. Somehow what you have to focus on, that once you are, again coming back to this graph, if you want you can just simply I will even provide you this graph. So what is happening, once you have created the offer for others, so at that time once you got informed about the new participant, that okay, new participant joined, so you created a peer connection for that particular new participant. Once you created the new participant, somehow you created the offer, you got the ICE candidate. How will you be getting it? Here, this is the whole process, like how you get the offer and all. So you got offer and ICE candidate, then you are just simply sending this to what? You are sending it to the signaling server. What will this signaling server do? This signaling server will forward it to the main user. As simple as that. What we'll do there, that's another case. But at least we are working on that part right now. So to this particular person, this needs to be sent, and so I have the message. Once I have the message, I need to get I need to call send to signaling server. This particular function will be sending it. I need to stringify it, so stringify, and I will be stringifying the message. Why am I stringifying? So that over here I can just simply write string and the job is done. Okay, so I'm getting the WebSocket and I'm simply sending it from here. This particular message will be received by the socket server, WebSocket server. Let me go to the server side. Coming back to this one. Oh, many things are here. Apps. It's not that difficult. Honestly, it's not difficult if you actually understand what is happening. Why it is happening. What is, I mean, if you actually understand why it is happening, then slowly you can just start writing the code. Coming back to this one, overall flow is okay. Coming back to this, what can I do? On the server side, I'm gonna be receiving the message. Okay, I received the message. Then what am I doing? I'm parsing that. Once passed that, I will check. Is this a normal process? The question is no. This is gonna be WebRTC process this time. That simply means I'm gonna be simply sending the data over here. WebRTC process. Inside this, I'm handling that. So I got the data. Now, once I got the data, I will be checking the type of the data as well. So switch statement again one more time. Switch statement really helps a lot. Coming back to this. So if data dot type, if that's triple equals to what? Data dot type. Okay, ठीक है. If that's triple equals to types dot SDP process. If the data type that I'm getting, if that's equals to SDP process, that means of course we are handling with we are dealing with offer, answer, ice candidate, and all these things. At that time, oh sorry, I'm not using if conditional. Data dot type, if that's equals to types dot SDP process, just like this. Then I have to do this, and what I have to do this, handle SDP process. It's pretty simple. Handle SDP process. What will I be passing here? I will be passing data dot payload, and the job is done. Am I sure? Think about it. What is the job of the, no, this is not what I want. What is the job of the server? The job of the server is that just simply forwarding the request. Okay, forwarding the request to the other peer, of course. So handle WebRTC process. Over here, when I'm actually getting the message, I pass the data, I got the message. Once I got the message, this passed message contains the data, this passed message contains the label, this passed message also contains what? To whom do I have to send this? So handle WebRTC, I have to add 2 over here. This 2 is gonna be nothing but a string, but yeah, it will be containing 2 over here, definitely. 2, and I don't think this is gonna be the best thing. Why? Again, this is gonna be string, but it is overall breaking the flow. Overall, I used to have yeah, it is breaking the flow. Because why is it breaking the flow? Usually what I have, I just have passed the passed message dot data. Now I'm having 2 over here. So in future I will have to just handle this 2. If in some cases I'm not sending the 2, then that's gonna be problematic, because this is the global handler, and that's gonna be problematic in future. So what I want, let me go to the front end side. Web app, lib, helpers, actually normal process. Not even normal process. Yeah, where am I handling this? Peer manager, right? Yeah, peer manager. Inside this, what am I doing? I'm just simply saying that send this ID. I'm going to send the ID in the data itself. So somewhere here, because I want to maintain the data structure. So data will contain the type, data will contain the payload, that this is the payload that I have to send, and this is the ID, to this particular ID I have to send. So this is how I'm gonna be going ahead, because otherwise the whole flow was breaking, and I don't want that to happen. What is the flow? I'm gonna be showing you that. Okay, this thing is done. Close this. Coming back to this backend. So over here, I was having to add this 2 over here specifically, and that was the breaking change that I was making, because usually what I'm doing, whenever I'm handling it, I'm just simply forwarding the data to the next one. I'm just simply passing the data, and I was having to pass the 2 over here as well. So what I did, I added the 2 inside the data itself. Coming back to this one, I will not be getting the 2 here. Just like this, I got my data. I will be checking the data type, that is the SDP process, and once this is done, handle SDP process. So the next job is gonna be of this handle SDP process, that it will be forwarding it. So handle SDP process will be handling the SDP process. That simply means, what does the server do? Server gets the request, gets the data, forwards the data to the other peer, and that's what it will be doing here. Okay, I will have to create it, by the way. So let's go to the helpers WebRTC process, and let me create that. Export function handle SDP process. It will get what? It will get the data. What is the type of the data? Interesting. What is the type of the data? The type data. Data type data, literally. Let me check. Data will have type, and data will have payload. Data can also have the ID, and that ID is gonna be optional, and the ID is gonna be string. Optional will not be problematic. Okay, so ultimately data will have this type as well. So once data is done, I will be just simply importing it here. Once this is done, coming back to this one, I got my data. The data type is gonna be nothing but a data. I can even just like this, and from here I will be forwarding it to the new user. this data type will be data, but there is a problem. What is the problem? The problem is I can destructure it. I will be having the type. Data will have the type or what? Data will have the type or what? Come on, for front end side, I will have to check what exactly am I sending. PR manager. Data does have the type. HTTP process. Let me directly send the payload. Yeah, payload and ID. Let's simply send them from here. Just a sec. Coming back to this one. Close this. Over here, instead of sending the data here directly, let me keep it empty for now. From here, what will I be doing? Data.payload, right? So handle.hdp, it is already data.payload is being sent over here. From here, I'm gonna be sending the payload as well as the ID. So data.id, though that is optional, but I'm gonna okay, data type, yeah, that's fine. So I'm gonna be sending the ID as well. Coming back to this one, I will be getting two things. I will be getting the payload and I will be getting the ID. Okay, once I got them, then type is gonna be what? Type of the payload. Let me make it any. I mean, payload may contain many things. What payload may contain many things? Payload will be containing the offer or the answer. Ultimately, what is the type of the offer and what is the type of the answer? It may contain any type. Okay, and then ID is gonna be nothing but the string. It doesn't really matter because whatever payload I get, I will be just simply forwarding, as simple as that. And but there is a problem. And what is the problem? Once it comes to this particular payload, so this payload itself will be having what? That's gonna be interesting. This payload may contain offer, this payload may contain answer, this payload may contain ICE candidate, ultimately candidate. How will you be deciding what that is? Because I'm not sending any type here. That's problematic. So I will sell it like this, that switch statement. Of course I'm gonna be using this over here, and payload dot payload dot type. I'll have to add the type anyhow. That needs to be done. Okay, never mind. Let me go to the front end side, so that I can just simply say that if payload dot type is the offer, do this. If I don't even need to do it. I got the payload, right? Let me do one thing. Get the WebSocket connection. WS is gonna be connections, and I already have the ID. So using the ID, I will get the connection to this particular user. You have to send it to, and the payload I have, and ws dot send. I'm forgetting my main goal. What is my main goal? My main goal is to just simply forward it. Don't do anything. Don't try to guess whether that is the offer or answer. Nothing. Don't worry about anything. Simply send it. Send it json.stringify and ws. Sorry, not ws. Payload. Payload. That is the only thing that you have to do. Any problem with this? No problem. You can definitely send the type along with this. Let me try to handle it on the another user side who actually gets this particular offer or answer or anything, and see how that person is gonna be handling this. So let me go to what is the problem here? Data.id. Handle process. Okay, let me come on, Vipendra. Let me not have them in an object. Let me have them directly over here. Just like this, and let me give them the type here directly, any type. Later I may be giving it the type as well. String. Will not through the any. Coming back to this one. Handle HDB process. Handle HDB process gets these things. String or undefined is not assignable to type of string, or undefined is not assignable to this. Yeah, that's right. So this can be undefined as well. Let's not make it undefined, rather let's come back here. It does exist. I'm forcing that. I'm telling it that it will definitely be here, but I can check make it like this as well, that if data.id exists, only then send data.id, otherwise just this string. This will also be fine. So if that exists, only then send that. Otherwise, how about this? The other situation can be just use double end over here. Oh no, that's not gonna work. So okay, let's go with this way. I'm just simply saying that, bro, if that exists, only then send that. Otherwise, just simply send an empty string and that's gonna be fine. Okay, what does this handle SDP process do? It simply forwards it. And now I will get it on the front end side. So now on the front end side, what will I be getting? I'm gone, just a sec. WebRTC process. I'm sending the payload and not this much. I don't have to just simply send this much. I have to send the message. I have to create proper message, and proper message in the sense the proper message that I'm actually getting. That simply means, let me be back to this process handler. Over here, what is happening? Handle WebRTC process, and inside this handle WebRTC process, I'm getting my whole data. It's breaking my whole flow. I just want to structure the things in the right way, but it's breaking that. But okay, let me check what I can do. Let me go to the server.ts. I'm getting this handle WebRTC process. Once I got this, the process is the WebRTC process, and I have I have my passed message over here. This passed message has two things: labels and the data. What I have to do? If the label is equal to WebRTC process, I have to handle it. Handle WebRTC process. Passed message.data. Let me do it a bit differently. When it comes to handling WebRTC process, why will I use it and for what? Most of the time it will be used for forwarding the things and all, right? So the WebRTC process is going to be a bit different. I'm gonna be passing the whole message from here. Okay, coming back to this, I will be getting the whole message passed the data. Passed message, gonna be any type, and I don't really care the type of the message. Once I got that, after that, if passed message dot data dot type, if that's triple equals to SDP process, in that case what I have to do? Handle SDP process and send the whole message, passed message here. Okay, once it got sent here, I will be getting the parsed message here. Again, keeping the type any, that doesn't really matter, because this data I'm getting from the front end side. I don't even have to care about the type. I have to just simply forward it. Once this much is done, the whole passed message needs to be forwarded to the user. But in that passed message, I have data. Inside data, I have 2, and that 2 needs to become from and needs to contain the ID. What should be the message like? Let me create the message structure. Message should be like this, that I will be forwarding from here. It should contain the labels. Labels dot WebRTC process. It should have the data. Data will have what? Data will have type. Type will have types dot SDP process. It will have payload. Payload will contain what? Payload will contain anything that I'm getting. Anything in the sense, suppose it can be offer for now, or it can be offer. Offer is gonna be equals to offer. Just suppose it can be offer or answer or anything. It can be offer or answer or ice candidate. just like this. And lastly, it should contain from, it should not contain to, it should actually contain from, that from this particular user it is actually coming from. From means what? From means there was a person who sent it, ultimately host. So the ultimately the person who is sending the offer, that person's ID over here, that simply means connection ID. How will I get the connection ID here of that person mainly? Connection ID of the person. Server.ts. I do have the connection ID over here. This is the connection ID that I have, that I got in the request. And in this case I have only one way, that I export it from here. When I'm actually exporting it from here, WebRTC. So this connection ID I need to send it to the other user. This is the first thing. And if I want to send it, so I need to pass the connection ID here as well. So what will I be doing? Handle WebRTC process will be taking two things this time. Handle WebRTC process will be taking the pass.data, passed message dot data, not like this, passed message dot data, and connection ID. Why do I need to have the connection ID? Because I have to send it to the other person. And what is the problem? It is just simply saying that it is not accepting. So over here, what I'll say, passed message, not passed message actually, I will be getting the data and I will be getting connection ID. Again, what is the type of data? I don't really care. The connection ID is definitely gonna be string. And let it be any type. Data will contain mainly what? Data will contain the type and the payload. So I can keep it like this, that okay, it contains the type. Type can be this. It's gonna be too much. So let me just have any over here. Once I got that, so data will definitely contain the type. If the data type is actually SDP process, that simply means I'm doing the job of forwarding the things. And once that is done, then handle SDP process will do what? Handle SDP process will be getting the data and will be getting the connection ID. Connection ID. Once it gets the connection ID, I'm gonna be back here. I will be getting two things here. I will be getting my data, and that's gonna be having type any, and I will be getting my connection ID, and that will have the type string. Okay, once this much is done, so message, label, data, type, SDP process, payload. Payload is gonna be nothing but data dot payload. From is gonna be what? From is gonna be the connection ID. Cut it from here, paste it over here, and done. How will I get the ID from here? Over here. So handle process, I already have the data. That data itself contains the ID as well, yes or no? That does, yeah. So data dot ID. Any problem? No problem as such. Now I have the message and message. Ooh, it's not, we have to forward the data, but we have to make some changes in that. And what is the biggest change is this, that this time inside data I will not have to, this time I will have from in the sense from this particular user, this particular offer has actually been sent. So message, labels, data, this. Okay, so what will happen? I will get this message on the what side? On the client side, and now I have to just simply handle this. Okay, so let's go to the client side, close everything. Client side, I have signaling.ts. Inside signaling.ts, I got the message. Okay, once I got the message, I got the message. Once I got the message, I'm handling it. I'm checking whether it has normal process or it is from WebRTC process, or message is from the WebRTC process. Handle WebRTC process. I'm just gonna be sending pass message.data here. Coming back to this particular thing, I will receive my data. Data will have data any type. Ultimately, it will have type. Type can be type. Oh, bro. You know what? Type can actually not be just type. Type can be asked to connect, request to join meeting. Type can be SDP process. Type can be actually many types. So let me remove it. Data itself can have many types. So let me make it any. Ultimately, the type will itself contain many types, and I don't want to have those types again and again here. And that is why I'm just making it empty right now. Later I may be making the types for it. Okay, for now let me remove it. Data, whatever data I'm getting, that will have any type. Okay, this thing is done. Look, the main reason that I'm not worrying about the type over here, because first of all I'm creating I'm having constant variables, so those constants are being used over and over, so no doubt type is definitely gonna be right. And apart from this particular thing, if I don't have any problem with the data type as well, I can create it, but then I will have to mention all the types over there. Send request data type, grant meeting join data type, ask to connect a data type. There can be many data types that can be done later on, but not now. Okay, coming back to this one, I got my data. This data contains what? Payload, from, and type. Yeah, it contains three things. So switch this data dot type. If that's equals to types dot SDP process, then what I have to do? Handle SDP. If you actually see, so the flow of the backend and the flow of the front end, that's exactly the same, and that is why I just wanted to maintain the flow. Process, handle SDP process, and data dot payload, and data dot ID, not ID, data dot from. I'm gonna be sending these many things. Handle SDP process. It's better to just simply give it the type. That is data that I send and data that I get. There is a difference between them. The data that I get, that will have from. The data that I send, that will have to. So it's gonna be like that. Coming back to this SDP process, I will have to create it. So let's go to WebRTC process, export function, handle WebRTC process. Really? Handle SDP process. I will get what? Coming back to this one, I will get payload and I will get the data from. I will get payload here, I will get the from here. From is gonna be nothing but a string. As for the payload, again I can specify it, but I'm gonna be keeping it any for now. Coming back to this, what I have to do here? Interesting stuff. What is happening? Handle SDP process. Now I have to check whether this is actually, this payload is what? Payload can be offer, payload can be answer. So the first way is that if payload has the offer, then do this, then else. If I mean, this is the normal way. If payload has the answer, then run this particular section. Else, if payload has the candidate, then do this. Else do this. I mean, whatever. So this way, and again this will work. But how will I implement the same thing using switch statement? Is there any way? So if I use switch statement over here, this so if I say payload dot offer, then it will actually give me the real object, and that means this will not work. So in case if I actually want to use switch statement over here, then I need to have type in the payload, so that I can just simply check that payload dot type, and that's equals to offer, then do this. That's equals to answer, then do this. That's equals to ICE candidate, then do this. Alright, so if you don't want to have the type, then you can go with this way, that if payload has the offer, then this will run. If payload has the answer, then this will run. And if payload has the candidate, then this will run. So this is the normal, way when you don't want to have the type. And if you want to have the type, then of course you can go with the switch statement. I'm gonna be going with the switch statement. That simply means the payload that I'm actually sending from the client side inside PR manager, I'm sending the payload over here. This payload, I'm gonna be giving the type as well. Type is gonna be candidate, just like this, so that I can use this payload like type anytime to just determine what kind of data this payload contains. Coming back to this one, type is gonna be offer. Why am I sending it? So that again it's personal choice, up to you whether you want to send it or not. Again, payload also contains the type, data also contains the type, data contains the overall type, like HTTP process. Payload is specific type. Okay, this kind of the type of this offer is the type, I mean the type of the payload is this type, just like that. And what will I do? This data will go to the backend side. When the data goes to the backend side, inside server process, the data comes here. Passed message data and connection ID I am passing from here, and coming back to this one, the data I have, connection ID I have, passing it to the handler process, data connection ID. Coming back to this message labels type HTTP process, payload data dot payload. This payload contains the type that I set on the front end side. That's okay. From, that's fine. I'm just simply forwarding it back. That simply means I will get it on the front end side. So handler, what is the problem here, bro? This data I don't have it here. Oh, no way. Let's keep it any type, that doesn't really matter. So where am I? Am I on the WS server side? Let me get rid of this. Coming back to this one, handle process, where am I? This is on the front end side, yeah. So handle HTTP process, I will be getting the data and all, and from coming, click what? Import it here. Once it has been imported, let's go here, and now I will have payload.type, and on the basis of that thing I will be able to decide what this is. Okay, great job. Next thing, the first way is that now I got my ICE candidates over here. Amazing job. So if you actually have a look what we've done, the host allowed the participant to join the meeting. Then what happened? The other participants got informed about the new participant, and new participant actually got informed about others, but we haven't created the offer for this. Of course, we have done only this much. We have done what? We have informed others about the new participant. We created the offer in ICE candidates. We just simply sent them to the signaling server. Signaling server somehow forwarded them in WebSocket, pure WebSocket. You have to manage many things. In reality, if you are using socket.io, it gets really simple. But okay, never mind. And once the signaling server forwards the message to that particular user receives the ICE candidates and offer. Now I will have to check, do you have the peer connection or not? If you don't have the peer connection, if you have the peer connection, great, because if you don't have the peer connection, I will have to create the peer connection, as simple as that. By the way, there is high probability that, because when the host allowed, at that time what happened, others got informed about the new participant. At the same time, new participant got informed about others. That simply means even at that time I have to create the peer connections for others, so that the new participant can actually connect to those people. But here, as soon as I get my ICE candidate and all, so I have to check whether the peer connection is already there or not. Most probably peer connection will be there. If the peer connection is not there, I will have to create it. But first of all, I have got this thing on the other user side. Let me handle this case. When the new candidate is being informed about others, okay, these many people are already in the meeting, so the new candidate will also create not one peer connection. New candidate will create peer connections for all those people. Having said that, it is a peer-to-peer connection. Peer-to-peer connection in the sense, if you want to connect it to 3 people, so you need to have 3 peer connections. Then all those 3 peer connections will be connected to those 3 people. So in peer-to-peer connection, one peer connection can only get connected to the one peer. Another peer can be connected to the another peer connection. So this is how the things are gonna be going on. It's not like you have one peer connection and that one peer connection can be connected to many. That does not happen. There is a way, like you can create a server, connect to the server, and the server will be connected to the others and all. Let's forget about that. I will even talk about it in future coming videos. But right now, it is a P2P peer connection. That simply means if there are 10 users, you need to have 10 peer connections so that you can connect it to all those people. Similarly, when the new participant got informed about others, that new participant needs to create as many peer connections as there are people in the meeting already. So what will happen over here? We have to handle this. So let me handle this part, okay? And once that is done, then we will continue from here on tomorrow. Let me create as many peer connections as there are people. So what is happening? As the host allows, at that time what happens? Signaling.ts message. Let me close everything. Once the host allows or denies, so at that time you get a message everybody, I mean new participant gets a message, that's right, and that message is kind of belongs to normal server process first of all. So if I click on signaling here and if I get the message, that will definitely belong to the normal server process. If I click here, so over here what kind of message that is? That is the message where handle inform new participant about others, where I'm actually informing new participant about others. So let's go here. So what am I doing here? When I'm actually informing the new participant about others, at that time actually doing nothing. First of all, set other participants. So in the state I'm just simply setting the other participants. Okay, I got the other participants. What I have to do? I have to just simply set them. And lastly, I have to create the peer connections. One peer connection, two, no. I have to create as many peer connections as there are people. So what will I do? I already created a function for creating the peer connection. I will even show you that. But before that, other participants dot for each participant. Now I have to create as many peer connections as there are people. So set create peer connection and participant dot id. So this way peer connections are gonna be created. What happens when peer connection is created? Let me click on this. This is the function, this is the code that we wrote, right? What we are doing over here, we are creating the peer connection, and once the peer connection is created, we are actually saving the peer connection. So it's not like we created the peer connection and that is gone. No, we are actually saving all the peer connections inside this peer connections object. So all the peer connections which are created, they will be here. So this way I will be able to know, okay, how many peer connections I have on my side, and I will be creating as many peer connections as there are people. So if I have 10 peer connections, if there are 10 people, I will have 10 peer connections, and those 10 peer connections will be connected to all those 10 people. So this is how it's going to be going on. And again, what happens just after that? Once you created one peer connection, then what will happen? You got your local stream. Once you got local stream, again, why do you need to have the local stream? So that whenever you create the peer connection, you are adding your tracks as well. Adding the tracks in the sense audio track, video track, so that whenever the connection gets established, at that time you are able to send your audio and video right to the other peer. And because of that thing you need to do, as soon as you add the tracks over here, so you are adding the tracks to the peer connection, you get the senders. As soon as you got the sender, you set it in the RTP sender. As soon as something changed in the peer connection, this on negotiation will be triggered, and then you will create the offer over here. Okay, once the offer got created, then you are just simply sending the offer to the what? You are sending the offer to the other participant, and this is how the things go on. Again, if the new participant is trying to create the offer, the new participant will not be able to create the offer, because if you join the meeting, other participant who is already in the meeting, that person will create the offer, will send the offer to you. Then once you get the offer, then you have to create the answer, you have to send the answer, that will get the answer, and this way things are actually going to be going on. Again, we have reached this far. What else is remaining? We have created the peer connection for others as well. Now what? Now this section. First of all, you will the other participants will receive the ICE candidates and offer. Then I will check whether they already exist or not. If that exists, that's great. Otherwise, I will have to create a new peer connection. After that, I already got the offer. Then I will set the remote description. So I got the offer. I will be setting the remote description. Again, if you are creating the offer, you have to set local description. Once you sent the offer to the other person, that other person will be setting the remote description. If you are creating something locally, that needs to be set to the local description. If you are getting something from remote side, from remote peer, you have to set it at remote description. So this offer is coming from where? Are you creating it on your own? No, you are actually getting it from the remote person, remote peer, and that is why you have to set it to the remote description. On the other side, over here, what were you doing? Over here, you created the offer locally. Yes. Did you get it from somewhere? No, you created it locally. And because of that thing, you set the local description. On the other side, when you sent the offer to the other peer in here, so you are getting the offer to the other person's side. And because of that thing, you are not creating it locally. That simply means you are getting it from remote side. Set the remote description. After that, create the answer. Are you creating this answer locally or getting in somewhere? No, you are creating it locally. So as you are creating it locally, you have to set the local description. Whenever the local description is set, your browser will start gathering the ICE candidates. Here I am talking about the second user. First user, what happened? First user, first of all, as soon as the host allowed, ultimately host allowed the user. then host created the peer connection, then host created the offer, then host created the answer, host sent the peer connections, offer or and ICE candidates to the new peer, ultimately the peer who wanted to join the meeting, and then ultimately peer 2. So peer 1 created created the offer and the ICE candidates, sent them to the peer 2. Now peer 2 receives them, and peer 2 gets the offer, sets the remote description, and then what it does, it creates the answer. Peer 2, the second user, creates the answer, sets the local description. Again, once you create the answer, set the local description. As soon as the local description is set, ICE gathering process will start, and ICE gathering process starts at the third place in the sense, first of all you created the answer, okay, then you added the local description, second, and then at the third place it started, as simple as that. So this is how it just simply goes on. And then you will get the ICE candidates. You already have the answer, you will be sending the ICE candidate and answer back to the signaling server. Signaling server will forward it to the peer 1. Once the peer 1 gets them, then you have to just simply ultimately done. You created the answer, you sent the ICE candidates, it will just simply set it here. Now both of them know about each other, and ultimately your peer connection will be ready. So few things are remaining. This whole section, this section, ultimately this section, and then sending this and setting the ICE candidates and all, this much is only remaining, and hopefully tomorrow it will be done. So this is how the things are actually gonna be going on. Quite a lot, I know, but I can't really do anything. How long has it been? Alrighty, it's been 2:55. Pretty impressive. 55. I was supposed to be sitting. Let me just keep coding for 5 more minutes, so that make it 3 hours and done. So over here, what do I have to do? I created the peer connections, ICE candidate and offer. I have to check once I get the offer or the ICE candidates whether the peer connection exists or not. So close everything. I'm getting on the other user side. That simply means inside the signaling server. I'm getting it from the server side. That simply means that is the WebRTC process. Inside the WebRTC process, that is the SDP process. Don't get confused. This is what we created earlier. Now the payload. This is what we are getting from the other user side. Other user created the offer, and now that user sent the offer to me. Okay, this is actually what happening here. So once I got the offer, so what I have to do? That is the SDP process. That is great, but I have to check. What do I have to check? I got the ICE candidates and offer. Then I have to check whether the peer connection exists. If exists, no problem. If it doesn't, create. So const. I have to check whether I have the peer connection or not for this particular user. How will I check that? I have peer connections over here. Peer manager, create peer connections, and I'm just simply setting it there. As I'm already setting the peer connections over here, right? So peer connections are set here inside this particular object. So using the ID, I can get the peer connections. Am I getting the ID over here? Of course I'm getting. The payload, I have the ID, this from ID. So using this ID, I can get the peer connection. So const peer connection is gonna be equals to what? Peer How will I send the peer connections? Peer manager, create peer connection. I will have to create one more function here. Export export function get peer connection. It will do nothing. It get peer connections, actually it will be just simply return peer connections. So it will be just simply returning them. So whenever I call this, it will be returned from here. That's great. Coming back to this one, I'm gonna be calling const peer connection is gonna be get peer connections. This is not enough. I'm gonna be passing it my ID, and once I pass my ID from here, cut it from here, let me go here. This should be get peer connection only. It will have the ID, it will get the ID. ID is nothing but gonna be just a string, and from the peer connections I will be getting the peer connection, and I will be returning that from here. Okay, coming back to this, I'm gonna be importing it, imported. So this way I got my peer connection. In case I don't have, then what? I will create it. So otherwise, if I don't have it, create peer connection. Again, this is again a function that I have already created. No need to worry about it. So it's pretty simple. Again, when I'm actually getting the offer from the other person's side, there could be possibility that this does not exist. So yeah, it's better to check it. I will be checking the peer connection. If I have the peer connection, that's great. Otherwise, what will happen? A new peer connection will be created. As simple as that. And okay, once I got the offer, then what do I have to do? Once I got the offer, then that's pretty simple stuff. Once you got the offer, set the remote description. Okay, great. I have the peer connection. PC dot set remote. Arey bhai. PC dot set remote description, just like this. And I'm gonna be setting the remote description with the payload dot offer. What is the problem here? Set remote description does not exist on RDCP peer connection. Promise. Async. Arey, nope, sorry. Async. Await. This is not needed here, but this is definitely needed here. If I'm creating one, I will have to await it. Okay, great. Still problematic. Okay, just a sec. Missing something. When I'm actually getting it, why do I need to await it? But let me try it. I'm just simply guessing the things right now. I'm not using quite my brain right now, but okay, I need to use my brain right now. Using the brain knowingly. Great. Okay, coming back to this. What is this saying? Set a remote description does not exist on type of wide or RTCP peer connection. Wide. First of all, I'm sure that I don't need this. Why? Because bro, I'm just simply getting it right from there. So I just have my peer connections over there, nothing else. Okay. Yeah, PC peer connections, RDCP peer connection, await local stream and all. That is fine. So coming back to this, over here, what happens when I'm creating them? When I'm creating them, it's just the same. So though I'm making it async because I need to await it, but at the end of the day, whenever I'm just simply saving it there, I need to return from here as well. Return PC. This was the problem. Why this was the problem? The problem was that I wasn't returning from here. So when I was just simply creating it, at that time, it wasn't getting returned from here. And that was the problem. Okay, that is fine right now. So this is it. So I got this. I even set this. I should be getting the event suggestions here. Set a remote description. Yeah, getting the suggestion. Setting the offer here and nothing else. Not the offer. Payload dot offer. Okay, what I did, simple, got the offer, set the remote. Now I have to create the answer and set the local description. Create the answer. How will I? Let me do one thing. Instead of doing it here, handle offer. Just like this. I'm gonna be passing my payload dot just payload dot data offer. Simple. Now I need to create it. I mean, it's no use just simply handling everything here. That is why I'm doing this. But this peer connection, I need to have it there. Oh, I'm gone. Payload data offer. Either I pass the peer connection. Let me pass the peer connection as well. I mean, I can get it directly, but it's okay. Let me pass it here. What should I? There are two ways. Either I pass the peer connection directly from here, or I just simply pass the ID, and using the ID I get the peer connection. So both the ways are here. So let me send the peer connection. Who cares? I mean, it hardly matters. Oh, I don't have enough space here. Let me handle it here itself. Otherwise, it's gonna be too much passing the things again and again. What I'll do, control C, 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 no, control Z, 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 Z. Okay, this much is done. And I'm gonna be cutting it, creating it a block, and just pasting everything here. Okay, so set a remote description is set. Now I have to create the answer. So const answer is gonna be equals to what? Answer is gonna be equals to pc dot create answer. Answer is created. Once the answer is set a local description. Oh bhai, pc dot set local description. I'm gonna be setting the answer. First of all, I'll have to check. I have to await it. Okay, this thing is done. So what are we doing? We got the offer. We set the remote description. After that, we are creating the answer. Why? We are getting the answer from the other peer. Now we have to create the answer so that we can send the answer to the other peer. What is the use of this exchange that we are doing here? When we get the offer from the other peer, we know about the other person. Now we have to create the answer so that we can send it to the other peer, and the other person can know about the data that we are gonna be sending. Most of the time, the offer that you send that contains the media type. Again, you can log the value actually offer. You can log the offer and you can see how many things it contains and all. We may be doing in future and all. I've done it quite a lot of times, so I know it does contain that. Okay, so I'm gonna be creating the answer. Why am I creating it? So that I can send it to the other peer. Why do I need to send it to the other peer? So that other person can know about me, about the data that I'm gonna be sending. Okay, and again, as soon as we set the local description, the browser starts gathering the process. The same thing happened here. You created the offer, not here, cut. What happened here? You created the offer, you set the local description, browser starts gathering the process. So created the offer, whenever the local description is set, browser starts the job, browser starts gathering the processes, and then browser sends the request to the instance servers, gets the public port, ultimately creates the candidate somehow, and then you get the candidates where? You get the candidates inside this particular event, and then from this particular event, they are just automatically sent to the other person. The same thing is gonna be happening over here. What we did, we got the offer, set the remote description, created the answer, set the local description, created the answer, set the local description. Once the local description is set, what do we have to do? Send answer to the other peer. As simple as that. Great job. And not only that, send the answer to the other peer. We have to do it, and we are inside a WebRTC process. So how can we send the answer to the other peer? Now for sending the answer to the other peer in the sense from where this message is actually coming from. So ultimately we do have from here. So let me create the message. Crazy job. Const message labels. Label. Okay, label is gonna be what? Label is gonna be labels. Labels is nothing but a constant that I have created. So labels dot now which process? WebRTC, or I'm playing with the answer. That is the WebRTC process. Okay, and data is gonna be what? Data will contain the type. What will be the type? Type is gonna be the HTTP process. So types, again, this is also a constant variable. Types dot, I have these many types, I'm gonna be using HTTP over here. Payload, this is the benefit of creating constants, that you can get the suggestions and you don't need to write HTTP process over and over. Payload will contain the type is gonna be answer, and payload will contain the real answer value. So answer and answer, that's it. Not abhinay. One more thing, to where do I have to send it? I have to send it to from. It's just think about it. This from is what? This from is the ID of the user from where you are getting the offer. Now you have to send the answer to that particular user, and that is why you are specifying to is gonna be what? To whom you have to send the data. To this particular from you have to send the data. From ID you can say. So I'm just naming it to ID. I could have named it from ID as well. So you could have named it like this as well, from ID. But as we've written the form, I mean not form, we've written the code, so let it be. But from is from ID, to means to ID. I hope you got it. This much is done. The message is created. What is the next thing? Send to signaling. I think signaling. I created it, didn't I? I created it here. I have to export it. Send it to signaling server, it simply gets the message, nothing else. Coming back to this one, send to signaling server json.stringify and message. Is this enough? Yeah, it is enough. So the message will be sent to the, what will happen here? Simple. You created the answer. Once you created the answer, so what you are doing? You are simply getting the answer. You are sending the answer to the signaling server. Signaling server will send the answer back to the user. Great job. Coming back to this is not done yet. By the way, we have sent the answer, but we have to get some other things done. What is that other thing? Is that we haven't said we have got this ICE candidate, right? Haven't we? We have got this ICE candidate, but we haven't done anything. And what do we have to do? What is the overall flow? The other person will send you the ICE candidate. You will get the ICE candidate. Then you will set the ICE candidate, and then you will create your own ICE candidate, and you will send the ICE candidate back to the other person. Why? Why this ICE candidate exchange needs to happen? Simple thing. ICE candidates, simply speaking, candidates, they are nothing but route, kind of a path that contains the information, that contains the public IP, public IP address, public port number, private IP address, private port number, and many other things. So what is the benefit of it? If you know about the public IP and port of the other person knows about you, so the connection is gonna be established. As simple as that. And that is why we need to set the ICE candidates, the peer connections to where? We have to set the peer connections to ICE candidates to the peer connection. But there is one condition. What is that condition? If the remote description has not been set yet, you cannot do that. Okay, just give me a second. Alright, so what I was saying, come on, it's too hot. Summer has come. Okay, never mind. Coming back to this, what I'm saying, there is really important thing. Once you get the offer, you set the remote description. What is the condition? This ICE candidate step always comes at third place. Again, if you just keep this particular thing in mind, I've been saying it from the beginning. I'm gonna be telling you this again. First you created the offer, first step, then you set the local description, and at the third step you get the candidate. At the third step you get the candidate, and similarly at the third step you will be setting the candidate. Third step, keep in mind. Okay, similarly what happened? You went there, here you got the offer, you set the remote description, and now at the third place you will be setting the ICE candidates. So at the third place you get the ICE candidate, and similarly at the third place you will be setting the ICE candidates. The reason is simple. Until unless you have the remote description set, you cannot add the ICE candidate. So if you want to add the ICE candidate to the peer connection, you need to have the remote description set, otherwise you will get the error. So this is the overall flow, that if you want to set the ICE candidate, make sure that remote description is already set. So the simple clue to remember can be, it will always will be at the third place. Offer got, first step, set the remote description, second place. Now setting mode, third place. So over here, once the remote description is set, you can come back here, and if the remote description is set, set the peer connection ID, ICE candidates. Otherwise, what happens if you don't have the remote description set? Then simply push the ICE candidates to an array. That array can be called pending ICE candidates. You cannot set the ICE candidate until unless your remote description is set. And if the remote description is not set, save that those ICE candidates somewhere, and later when the remote description is set, just simply set them. As simple as that. I hope it does make sense. And similarly over here, you create the answer, first step, you set the local description, second step, and ICE gathering start at the third step. So always and always ICE gathering step will happen at the third step. You will create something, okay, then you will set that, then you will get the local description. Similarly, you got the offer, you set the remote description, and then you can set the ICE candidates. So either you are getting the ICE candidates, you will get at the third step, or you are setting the ICE candidates, you will set them at the third step. I hope it does make sense. Coming back to this, over here, ICE candidate. So you are getting the offer, that's great. Apart from the offer, you are getting the ICE candidates as well. Yeah, you are getting the ICE candidates as well. So over here, what will you be doing? There could be possibility that if pc dot remote description is not set yet. If this is not set, then what do you have to do? You have to store them somewhere, and if that is set, then okay, I don't really worry about anything. If that is set, add them directly. Adding in the sense pc dot add ice candidate. I will get my candidate. Candidate means what? Candidate means payload dot candidate, right? Payload. I'm getting payload dot offer. Yeah, so I can just simply add it here, payload dot candidate. So I can just simply add it directly here. But in case if the remote description is not set yet, so I will be doing what? I will be, let me do one thing, create a peer not peer connection, let me create a pending ice candidates here. So inside WebRTC process const pending ice candidates, just over here, and this is gonna be nothing but array, and ice candidates. What is the type of this? Forget about the type, doesn't really matter. Pending ice candidates. And what will I be doing? If remote description is not set, in that case pending ice candidates dot push. What will I be pushing? I will be pushing payload dot ice, no, payload dot candidates. Why am I pushing them there? Because the remote description is not set. You can only set the candidates when the remote description is set. You get the offer from the other peer, you set the remote description, then you can add the ice candidates. But there could be possibility that you got the ice candidate before you got the offer. So once you got the ice candidates before you got the offer, what you will try? You will try to set the ice candidates, but you will not be able to do that. You will get the error, and that is why you need to check whether I got the offer or not, and not only that, whether I have set the remote description or not. Once I have set it, I can add it. If I haven't set the remote description, push the ice candidates to an array, and later whenever I'm gonna be setting the offer, at that time what can I do? At that time I can also set the, because when I set the remote description, when I get the offer and set the remote description, after that I can add the ice candidates. So what I want, over here we have just simply, when we got it, if the remote description is not set, push to the ice candidates array. Otherwise just simply set it. It can be done as well, until unless remote description is set. Okay, and let me do one thing, cut it from here, let me make it like this, and overall things are done. Yeah, coming back to this one, when you are setting the offer, so you got the offer, you set the remote description. Once you set the remote description, now you can add the ice candidates as well. So what you can do, you have already ice candidates where you have set the ice candidates inside this pending ice candidates, because you have set the remote description over here. After that you can just simply add this. So you will do pending ice candidates dot for each, and you will be getting candidate from here. Once you get the candidate from here, pc dot await pc dot add ice candidate and candidate. What is the problem? Pending is please has any type, तो ठीक ही तो है. Okay, just a sec. I don't know the type of ice candidates right now, so I'm gonna be making it like this. Await expression only allowed within the and the top levels of modules. Did you mean to mark this as async? No. Okay, fine. So this is how it's gonna. I don't know the type of ice candidate. What is the type of ice candidate? RTC ice candidate. I hope so. This is gonna be an array. Sometimes I do guess right. RTC ice candidate is the type of the ice candidate. So what I did, once the offer is set, now you can simply add the ice candidates and all. This is how it just simply goes on, and that is it. This is done. We have this last section, answer remaining. What we will do here? Okay, what have done? We've got the ice candidates, we got the offer. Once we got the offer, we set the remote description. Once the remote description is set, we created the answer. We set the local description. We got the ice candidate. How will we get the ice candidates? As simple as that. As soon as you set the local description, coming back to this one, as soon as you set the local description, ice gathering process starts, and whenever ice gathering process starts and when you get the ice candidate, pc.on ice candidate gets triggered, and from there you are gonna be getting the ice candidate and you will be sending it to the other peer. Okay, are we doing the same thing here or not? Let me check. Ice gathering is started. I got the ice candidates. Send the answer to the other peer. Have we done that? Yes. Where have we done that? Here. we got the offer, we set the ICE candidates, that's okay. We created the answer, we set the local description, that simply means I will be getting what? I will be getting ICE candidates, okay. And then I'm creating the message with the answer, and simply sending the answer back. Okay, over here we set the local description. Does that mean browser started gathering the process? Yes. Are we listening for on ICE candidate event? So let me go here. This is where we created the peer connection, right? So if I come back here, if I check, are we listening for this? Yes. Are we sending the ICE candidate to the other peer? Yes. Whom are we sending? To this particular ID. What ID? The ID that we get over here. The ID that we get over here. That simply means whenever I created the pair connection, automatically I'm sending the ICE candidate. Yes, that is being sent automatically. So over here I called a method called create peer connection. I gave it the from means from ID. Okay, that the naming is a bit confusing, sorry, I will change it later. So whenever you create peer connection, you pass your ID. Once you pass your ID, you get the ID over here. To this ID, ICE candidate needs to be sent. Are they getting sent? Yes. That simply means you are sending your answer from this side. Specifically, you are also sending your ICE candidates from here. What will happen? They will go to the signaling server. What will this signaling server do? You have already written the whole code for the signaling server. If I go to the signaling server, what happens? Signaling server server.ts server.ts. So over here you will get the message on the server side. Yes, once you get the message, you will check the label whether that is the normal process or WebRTC process. This is the WebRTC process. You will go here, inside that again you will get the connection ID, because you will be telling that from this particular user this is actually coming from. So once you got you have the connection ID, you are handling the SDP process. Once you have that, you are just simply creating the message and you are just simply forwarding it to the other user. To whom? To the user whose ID you are getting inside the data, because it's like from the front end side you are sending this ID already in the you are sending the data.id or data.to. I will just a minute. From the front end side I am not sending data.id. From the front end side I am sending data.to. This is the good benefit of creating the types, because I was saying that data.id, I'm not sending data.id, I'm sending data.to. Let me even show that from the front end side. How can I check it? Over here, when I'm sending the answer, so what am I sending? I'm sending to. So whenever I'm sending the answer, or I'm sending the offer, or I'm sending the ICE candidate, at that time data contains to, data does not contain the ID. So over here this data.to should be right, and from connection ID, that is fine, and this will be forwarded to the other user, that means first user. So ultimately what will happen? You sent the ICE candidates and answer to the first user. Signaling server got that, signaling server will forward that, and once signaling server forwards it, the first user will get your answer. Okay, first user gets the answer. Again, once you get the answer, you have to set that again. Where are you getting this answer from? Are you creating it locally? The first user. Is the first user creating the answer locally? No. Where is the user getting the answer from? From the remote peer. That simply means remote description needs to be set. Okay. Again, you are also getting the ICE candidate, but ICE candidate step will happen always at the third place. Again, same logic over here. Once you got the ICE candidate, check whether the same thing you checked over here. The same logic. Right, the same logic comes back here. The ICE candidate, either you get the ICE candidate or you set the ICE candidate. That will always happen on the third step. So you got the ICE candidate, first step. You set the remote description, second step. Now the third step will come for this ICE candidate. As simple as that. And coming back to this particular thing, once it comes to adding the ICE candidates, you will be checking whether the remote description has been added or not. If not, where do you have to push them? Pending ICE candidates. That's the same thing we did. And if that is added, then okay, you can just simply add it. So coming back to this, what will you do? You will first user will receive the answer. Amazing job. First user will receive the answer. So let me check. Go here, go to the client side, and what will happen? Signaling.ts. That's gonna be WebRTC process. That's right. And inside the WebRTC process, that's gonna be SGP process. That's right. And over here, what will that be? Will that be offer? No. Will that be answer? Exactly yes. Will that be candidate? No. That's again, that will be candidate. That that can be candidate, but we have already written the code for that. What is the code remaining? The code for the answer is remaining. What do we have to do here? Once the first candidate receives the answer, then what does it have to do? It has to set the remote description. Got it? So pc dot set remote description, and payload dot ice, sorry, candidate. I have to give the types properly once this is done. And then once this is done, then you can just simply set the remote description. So once this is done, I'm gonna be setting the remote description as well. So if there are pending candidates, in that case I'll do for each and async, and from here I will get the candidate. Once this is done, once I got the candidate, await pc dot add ice candidate. I'm gonna be adding the candidate, and this is done. Overall things are done. Let me keep it inside the block scope as well, just like this. So this is how it's gonna be going on. Anything else remaining? No. Does it mean now if I start my, the WebRTC connection is going to be established? Yes. One thing is missing, that is listening for this on track. We are listening, but we are not setting the streams and all, but we can still check whether the WebRTC connection has been established or not. Let me check now. Again, there could be like I made errors. Overall logic is done. We've written that, but there could be something that we missed, and then we will be getting errors, and fixing it will happen tomorrow. I'm done today. I've written the whole logic. Let me check. I can still check. Let's see whether things work or not. Bun dev front end is running. Come back to this particular section. Keep it here. Come back to this particular section, and keep it here. /meeting/1234. Let's go to the meeting. Control C, Control V. Let me do it. Let me have it inside the Chrome itself. Let me paste it here, and another user will get the request. Does the user get request or not? Here we are. Let me keep it. Come on, yaar. Here we are. Keep it here. User doesn't even get the request. Let me restart the server. Coming back to this one. But dev server starts. Reload the page. Once the page is reloaded, reload this page as well. I should be getting a request here. Allow. The users are added. Now I can check whether Chrome WebRTC internals. Oh, it hasn't even started yet. We are definitely missing something. Not missing something. The process is not working the way it should be working. We have written the logic. The thing is that there are some bugs in the logic, so we have to just simply figure it out, and that thing will happen tomorrow. Chrome WebRTC internals. Yeah, if the WebRTC connection was established, I should be getting the stats over here, but I am not getting. That simply means what could be the problem right now? Peer connection got established. The peer connection is not being created the right way. Okay, could be anything. We will log the values and all tomorrow. Let's call it here for today. How long has it been? It's already been around 3 hours, 27 minutes. Crazy stuff. Thank you very much, everybody. Now I'm gonna be catching up after half an hour. Not half an hour. I have to just get busy doing something else or the other. So I'm gonna be catching up after some time. I will definitely be back and just go live and all. Until then, take care. See you. Bye bye. Keep up the good work. And don't worry. Once you understand the overall logic, it's gonna be easy. One more thing. I can do one thing here, and that is if you actually want this, the whole diagram and all how it works, I can share it, and let me do that. So anyone with the link can do what? Publicly viewable. Oh bro, literally. Even if I want, I can't share. Can edit, can view. I should be able to do that. Can't set a view only while link editing is on disabled first. Can't I share it? Coding the code is the author. copy link. I have copied link, but if I share it, others are gonna be able to edit. Anyone in the coding team, okay, anyone with the link can edit. Anyone with the link can edit it. I'm not gonna be sending it. Hopefully you will not edit it, otherwise let me do one thing. Let me create a duplicate. I cannot do that, so let me go to the home. I already have this duplicate. Let me click on this, the same file I have. The thing is that, okay, can't I click on this, reload the page? This is the overall flow. If you actually want to create on your own, then you can just simply follow some tutorial and understand with this. But for some reason it is not clickable. Nothing is clickable. Literally, what is the problem? Control W, 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 W. Let's simply delete everything. Coming back to this, let me click on eraser. Okay, copy of WebRTC flow. What is the problem? I'm gonna be copying the link. I'm gonna be sending it to you. Hopefully you will be able to see that. Am I facing the network issue right now? Nope. So what is the problem? Okay, and in the next live stream, I will just simply add it in the description, so you can just simply check this thing out. Otherwise, just simply comment to me. If you actually want it, I can just simply share the URL with you. Alrighty then, that was it. I'm gonna be catching up soon. Until then, take care and bye bye.